Goldman Sachs is a place where macroeconomic events are studied and analyzed, where transactions are conducted, where risks are measured. We are a wholesaler of risk. We need to be measuring, factoring, analyzing, and monitoring risk.
Customers call us, patients call us, members call us, and you can imagine a team that's just buried under the weight of thousands of call recordings.
We're expecting to transfer around 300 to 400 petabytes to the cloud. It's hard to even describe how big that is.
The digital innovation team's objective is to find new technologies to create differentiated experiences for our guests.
Google Cloud was very impressive to us. It allowed us flexibility in storage and compute scaling.
Now our team can look at hundreds of calls a day in minutes instead of weeks.
You basically have all these building blocks already existing that Google provides you that helps you to build a product faster, it helps you evolve faster.
Google's been able to both meet our needs in the moment and yet also be a great thought partner about where this could go over time.
Google Cloud allows us to readily access our data and use that data to create personalized experiences. Post-COVID, we've seen a 9 times increase in the amount of traffic. Now with Google Cloud, we've got the capability to easily scale our environments to support increased usage.
I think this is very much going to be an open and evolving long-term relationship between Google and Twitter.
Google's made it possible for us to reach the exceptional customer experience in a way that hasn't been done before.
Hi, everyone, and welcome to our customers, partners, and the data community. I am thrilled to welcome you to our Data Cloud Summit, where we'll be exploring ways to use data to drive limitless transformation. I am Anita Kibunguchi-Grant, and I'll be your guide today. I am so happy to be coming to you live. Be sure to check out the full agenda on the main page of our website, where you'll also find our on-demand content. At the close of the day, join us for a demo that showcases how we can use data cloud technologies for the best customer experience. And also a big thank you to our partner sponsors. Head over to our sponsor showcase throughout the day to discover more about their incredible solutions. We are so proud of the depth and breadth that we can offer businesses thanks to these partnerships. And with that, let's kick off our keynote and welcome Garrett.
Thank you, Anita. Today, every organization on this planet, and that's not 75 and not 90%, but every company is going through some form of digital transformation. And the key is that to transform, we cannot apply technologies and architectures that are rooted in outdated paradigms. There are 3 paradigm changes that need to be brought together to unlock the unlimited possibilities that data holds. First, let us get one thing right out of the way. Everyone has big data, and at the same time, your data will never be as small as it is today. Data is available in many formats. It's provided in real-time streams, and it spans across data centers and even clouds. Yet all this data needs to be brought and connected together. And this goes beyond the data that you are working with today, because having data, it's a decision. Think about how many of the signals available to you could be digitized. How much data could be generated through constant experimentation and apps? How much data do you share with your network and partners? The bottom line, data is limitless. Second, the ways that you can work with data will continue to expand. There is no longer one single and dominant way of working with data. From machine learning frameworks, programming languages, frameworks for data engineering and real-time stream processing, to building data-driven apps. It's not about just one API or one framework. It's about how it all comes together on a common platform. And this is why we see the rise of the data engineer. It's to connect all these workloads, and it is one of the fastest growing jobs in technology. And we are so proud to share with you that Google Cloud's data engineering certification was just recently named as the #1 top paid certification globally. Because data workloads are truly limitless. And third, your data will reach just about everyone. All your employees, all your customers and partners, suppliers, through smart applications, analytics, alerts, and data networks. Data reaches beyond the boundaries of your organization. In a recent 7-day period, over 4,500 organizations securely shared more than 250 petabytes of data with BigQuery. And that means that your data landscape, it is a mission-critical part of your company that needs to dynamically scale at any point with the highest SLAs and at top performance. The reach of your data is limitless.
And you're absolutely right, Garrett. Systems today were not designed to meet the demands of this scale and complexity. And in a race to keep up with the data demand, many organizations fall into the trap of adding more fragmented data silos and excess capacity, which just compounds the problem, adding cost, complexity, as well as compliance and security risk. We can see that the data to value gap is increasing as more and more limits are being put upon data, multiple workloads, and users.
And to close this gap, organizations need a data cloud that adapts and scales to the new paradigms of limitless data, any workload, and for everyone. You need a data cloud that can scale elastically to any amount and any demand of data, that uses the best of machine learning and enables all workloads, and uses the best databases to build smart applications. All of that with maximum reliability, scale, and security. A data cloud that is simple, limitless, and intelligent. That's why every business is going to need a strategic data cloud that meets these demands. And at Google, it is our mission to build one-of-a-kind services. And this requires approaching data with an innovative mindset and supporting an open partner ecosystem approach. And this is why Google is uniquely positioned to be your data cloud. The work that you have done has gone way beyond these limits of the past. Every single second, BigQuery customers are analyzing 110 terabytes of data. Bigtable customers process more than 5 billion requests per second at peak. Firestore has more than 250,000 monthly active developers using the service. And through BigQuery and Vertex AI, we have seen a 2.5 times increase in deployed machine learning models compared to 2020. And all this incredible momentum shows one thing. Google Cloud is the data cloud for your transformation.
And I could not agree more with you, Garrett. And our customer momentum also shows this. Innovative brands and leaders across every industry are choosing Google as their data cloud. Leaders like Walmart. Walmart gave their data the BigQuery treatment to reduce processing time by 23%, closing financial books in less than 3 days. Niantic, publisher of Pokemon Go, leverages 5,000 spanner nodes and thousands of GKE nodes at any given time, supporting millions of players. And Tokopedia started as a digital marketplace and has since grown to cover fintech, payment, and retail. Using Google Cloud, they reduced computing costs by 25% and improved time to analysis from 2 months to 2 weeks.
It is truly fascinating to hear what our customers are achieving using Google's data cloud. And with that, let us welcome Ignacio Garcia, the CIO at Vodafone. Ignacio, welcome. Thank you for joining us today. Can you tell us what big data challenges you are facing today?
Many thanks for inviting me. Let me just explain who we are. So we are the largest pan-European and African telecommunication company. We operate in 21 countries. We partner with mobile networks in another 52. We have over 300 million customers, over 28 million of fixed broadband customers, over 22 TV customers, millions again. And we also serve 142 million IoT devices. So as you can see, it's a very large footprint, both in the customers and in the number of countries where we operate. And as you can expect, that translates in a lot of data that we have to manage, which will be one of the things that we'll be talking. So last year, for example, we had to process 12.2 exabytes of data to actually serve our mobile customers, and 87.8 to serve all the rest of fixed data. And that is a total of over 100 exabytes of data to do all our operations in 1 year. And then you have one dimension that is the geographical and the amount of countries where we operate, the amount of customers that we have to serve, the size of the data, and you need to add the number of silos that we have. So we have a lot of legacy systems that are coming from different acquisitions and mergers, and that is the complexity. So a lot of customers, a lot of countries, a huge amount of data and silos.
Let us talk more about how you are using Google's Data Cloud to solve for these challenges.
This is a very good question. And again, there are no products out of the shelf that solve our problem, and we are co-innovating. So let me break down your question in 3 areas. So the area number 1 is the data logistics. So it's obvious that with all of these geographies, with all of these legacy systems, getting data out of all of these places, putting that data in the Google Cloud at the right time with the right quality, and making sure that you can monitor all of these pipelines at a scale without including more people is a big challenge. And for that, we create something that is called Dynamo. And Dynamo, we are doing all of this engineering to actually do all of this connectivity. And this is powered by 2 main technologies, so Data Fusion and Data Pro, out of your catalog. So that is one section, which is the data logistics. The section in the middle, and is maybe the most important, is like the heart of this, and it's where you have the data platform in GCP, and we are running BigQuery and using BigQuery as the main calculation engine. So the power of BigQuery to do all the calculations that the different models and the different reports at the same time is asking and us is fundamental for the whole model to work. And then the third layer in the top is how do we make sure that we can use our data science to create as many models as possible to actually resolve as many questions from our customers as possible. And to do that, we have created something that we call the AI Booster. And that AI Booster is based on Vertex AI technology.
That is so awesome to hear, Ignacio. You talked about hundreds of use cases. Can you tell us what this means in terms of business value for Vodafone?
No, many thanks for this question. I think that our customer experience, the customer satisfaction are 2 things that are embedded in our DNA, and there are 2 things that now we can do better than before. For example, we can be more responsive to our customers' needs and launching new products because we know what they are, and making sure that rollouts on things like our 5G network affect the customer that really need that service based in the usage profile that we have there. So I think that customer experience, customer satisfaction, absolutely number 1. The second one is our overall total cost of ownership to manage this 100 exabyte of data a year that we have to be managing. I mean, we have a scalable model that is very solid, where we are basing in engineering and in automation the way how we're managing all of that data rather than in humans, which means that there are less errors and means that the cost is lower. Just to close, I would like to highlight again that this is a long journey. You don't do these things in 1 day. We have been learning what new problems we have to affect. And it's great. It's great to see all the engineering teams working together and finding ways to resolve problems, because every day we have a new challenge. I mean, we are in that journey. So many thanks.
Thank you, Ignacio, for choosing Google Data Cloud. We look forward to keep on innovating with you. Now, let us get to the most exciting part of today, the big data cloud innovations to match the limits of data, multiple workloads, and reach. And let's kick it off with the first announcement. It's the preview of Big Lake. It's the next step in removing the limits of your data. Today, data management across warehouses and lakes, it creates silos with increased risk, cost, and a mismatch of enterprise data management features. Big Lake is a data lake storage engine to unify data warehouses and lakes. And it extends BigQuery's capabilities to open file formats like Parquet and ORC, and to open source processing engines like Apache Spark. built on BigQuery and decades of building cloud-native analytics infrastructure. Big Lake enables fine-grained governance, it works across clouds, and it provides an open interface to work consistently across analytic runtimes. And you can use it with Google Cloud technologies and open source engines. With Big Lake, you get the benefit from the power of BigQuery to build an open lakehouse architecture. Our second big announcement is all around Spanner. Spanner processes 1 billion requests per second at peak with scale, global consistency, and up to 5 nines of availability. And we are democratizing the access to Spanner by adding granular instance sizing, a Postgres interface, and most recently, Spanner committed use discounts. And today, we are thrilled to announce that Spanner Change Streams is coming soon to all of you. Spanner Change Streams enables you to track changes within your database and to easily access and integrate this data with other systems. So that means that you can easily replicate database changes to BigQuery for analytics and to trigger in real-time downstream application behavior.
And that is so exciting, Garrett. Next, to help you remove the limits of your workloads, we're announcing innovations for Spark on Google Cloud. Now generally available, this is the industry's first auto-scaling serverless Spark. Now companies like OpenX, the world's most dynamic ad exchange for data and identity, can significantly boost productivity while reducing infrastructure costs for data processing and data science workloads. Serverless Spark also allows for interactive development through Vertex AI Workbench. These innovations allow customers to launch a serverless Spark session within their notebooks and interactively develop code. Further innovations will bring Spark to BigQuery. This Big Spark capability allows every data analyst and data scientist to run unified workloads from within the same environment. We aim to make Spark a first-class experience across Google's entire data cloud, from BigQuery to Vertex AI, to enable customers to innovate without limits. And be sure to check out the demo session later today and get your Spark on Google Cloud. Moving to AI and machine learning, we are excited to announce the availability of Vertex AI Workbench. With immediate access to data analysis from Vertex AI Workbench, whether in Spark or BigQuery, data scientists can now build and train models 5 times faster than on traditional notebooks. We're also enhancing our ML ops capabilities and expanding to include BigQuery. And so today, we're introducing the preview of Vertex AI Model Registry, a central repository for discovering, using, and governing custom machine learning models, including those in BigQuery ML. And with Vertex AI Model Registry, you can now directly deploy your BigQuery ML models to Vertex AI Workbench.
Let's now turn our attention to our innovations to remove the limits for reaching more users. And we start right with you, the developers. We are thrilled to announce the preview of Cloud SQL Insights from MySQL. Cloud SQL Insights is a simple and open tool that enables developers to quickly understand and optimize performance on Cloud SQL. And Cloud SQL Insights is available at no additional costs for the most recent week of your database's history. And support for MySQL joins an already existing and thriving ecosystem for Cloud SQL Insights for Postgres. We believe that data and insights should be available to anyone making a decision, which is why we have an initiative that we call Big BI. For all of the business analysts and analytics professionals, to all of us data geeks, we are unifying our BI portfolio with the integration between Looker, Connected Sheets, and Data Studio. And this integration will provide Data Studio and Connected Sheets access to data via Looker's modeling layer, providing easy and consistent access, trusted answers from the freshest available data. And now, let us welcome Mayank Gandhi, the Machine Learning Director of Wayfair. Hey Mayank, it is so great to have you with us today.
Hi Garrett, thanks for having me.
Mayank, I have learned that insights into data is fundamental to Wayfair's relationship with your customers. So tell us more about how you are scaling the use of data and AI.
At Wayfair, delivering data-driven and machine learning-powered experiences is in our DNA. Data is intrinsic to realizing value from ML. We leverage it to serve our customers across their journey with Wayfair, from personalized recommendations to customer service. We do so by building ML into the fabric of our decision making, learning from our customers about their needs, continuously improving our product catalog, and better partnering with our suppliers for delivering a world-class experience. My team serves a large community of data scientists, ML engineers, and data engineers at Wayfair, who are working together to deliver such experiences for our more than 31 million active customers across more than 22 million products. This ML community at Wayfair expects a data and ML ecosystem, one that is robust for daily needs, and that can scale easily for peak moments such as Way Day. The partnership with Google has been a great accelerant for our data and ML capabilities.
And how does data and AI remove the limits of your customer experience?
We use a range of Google's products today across our data and ML lifecycle, from BigQuery for analytic data, Dataproc for Spark, Vertex AI for model development and training, to Looker for driving business insights. BigQuery in particular has given us the ability to balance between both scale and performance. It is well integrated and serves as the core data layer for developing and training models. In fact, today we serve billions of features per day for a range of ML solutions, and BigQuery plays a critical role in it. On the other hand, with Vertex AI, for example, we have observed 5 to 10 times faster training runs with tens of millions of data sets distributed across clusters with little code written to achieve this scale. Our data scientists have more trust over their ecosystem and have begun to deliver amazing, highly scalable solutions built on top of Google's offerings. Most of all, with Vertex AI, we no longer need to spend effort solving complex infrastructure challenges as it abstracts those complexities away for us.
Mayank, can you tell us a little more of how you're using data and AI to continuously innovate?
Sure. Wayfair has an incredible pace of innovation. And to fuel that, our teams are constantly experimenting and learning to improve our customer experiences. We are constantly evaluating what is working and what isn't. Identifying these signals sooner and being able to iterate faster gives us an advantage when serving our customers' needs. For example, providing personalized recommendations that highlight the perfect product that our customers are looking for early in their shopping journey is an impactful outcome. These recommendations are powered by ML, which is an iterative process. Therefore, the ability of our engineering and data science teams to iterate faster through the life cycle gives us the needed velocity to pilot and test new solutions. So far, we have adopted Vertex AI Workbench, Vertex Training, and Vertex Feature Store components, along with several of Google Cloud's data offerings. Together, these have accelerated our iteration velocity and, by extension, the pace we can innovate, allowing us to better deliver experiences for both our customers and suppliers. Wayfair is still at the early stages of a phenomenal growth trajectory, and these significant improvements to our data and ML ecosystem is allowing us to better prepare for the huge market opportunity ahead.
Thank you, Mayank. We are excited to continue our collaboration. At Google, we know that limitless data, multiple workloads, and reach comes only with an open ecosystem. And that's why, together with our data cloud ecosystem of partners, we are helping customers to remove the limits of skill development, data sharing, and technology integrations. We have over 700 tech partners powering their apps as a part of our Build with BigQuery initiative. And we are helping our tech partners to get started with dedicated access to engineering teams, go-to-market support, and co-marketing. And now let's thank all of our sponsors, especially our premier sponsors, C3 AI, Databricks, Deloitte, Elastic, and MongoDB. We are excited to drive big innovation with you. And for more great news, last September we announced a partnership with C3 AI. So let's check out how this is helping our customers now.
When we launched this alliance with Google Cloud, our goal was to go to market with a complementary set of solutions and capabilities. We provide highly tailored, personalized applications that solve real-world industry problems in market segments that are innovating with AI in their space. The C3 AI applications leverage the full power of Google Cloud services, including the Kubernetes engine, data services, including BigQuery and Vertex AI pipelines. We're excited because the benefit of our applications, combined together with Google Cloud's AI and analytics tools, provides a unified experience that helps customers realize value quickly and solve industry-specific business challenges. A national financial services institution was looking to improve their ability to identify credit risk and predict defaults before they chose to work together with Google Cloud and C3 AI. Because of our joint ability to integrate both internal and external data signals, anticipate credit risk using ML algorithms, and propose appropriate responses to mitigate the credit risk, the institution has potential savings of $55 million.
Really excited to be a part of the Data Cloud Summit and the opportunities of bringing the value of AI to our enterprise customers, and doing that with a world-class partner, C3, running on a world-class cloud-based set of capabilities, that of Google Cloud.
As you could see from all that we have spoken about today, the future of data has limitless possibilities. And this is why we are building Google's Data Cloud together with you. Tune into our strategy sessions for more details on the announcements that you have heard today. Dive into our breakout and customer architecture sessions and get access to hands-on content. Thank you for joining Anita and I today. We are thrilled to be on this journey together with you. And finally, stay tuned for our live Q&A, where you see Anita and I answering your questions over there.
Guess what? We're back and excited to continue with you all. And just in case this is your first time tuning in, I am Anita Kibanguchi-Grant, and I am serving as your guide for the event. I am live and set in Sunnyvale, California, and I'm joined by Garrett Kazmaier.
Hey, it is great to be back, and we are really excited for what is coming next, because we have shared all of our innovations with you, and now we want to hear from you and answer your questions.
Agreed. And before we jump into the live Q&A, just a reminder to submit your questions into the question box below the video player. We'll be pulling questions and answering as many of them as possible over the next 20 minutes. And while we give a chance to submit questions, I have one to kick things off. Are you ready, Garrett?
Let's go.
All right, let's do this. I love this first question because it's around Data Studio and Looker. And so let's go ahead and jump in. So with Data Studio part of Google Cloud and the announced Looker integrations, how should users think of the two platforms?
That is a great question. And actually, users should think in terms of choice. Data Studio is our self-serve dashboarding service, and it has millions of users already. Looker is our enterprise BI platform. It is multi-cloud and it's completely API-driven, so you can even build applications with it. And it has this unique modeling language called LookML, through which you can build semantic-rich and reusable data models. So now with the project Big BI, Data Studio and Looker are coming together on the experience level, but also Data Studio can now connect to LookML models directly.
Couldn't agree more, Garrett. And so we have another question up, and this is from Fiona. May I know what is the difference between Data Lake and Big Lake? And for our viewers, Big Lake is this new announcement we just made here at the Data Cloud Summit. So Garrett, tell us more.
All right, and thank you for asking, Fiona. Big Lake is one of our key announcements today. And so Big Lake really is you can think of it as a data lake storage engine almost. And the key point is that basically we are extending out BigQuery's base layer for which you can do fine-grained access control, data management, performance accelerations, and consisting data modifications, DML, on top of data lakes. And it even extends beyond Google's file storage in GCS. It also extends to other clouds likewise. So the difference is that you can now have your data lake and open source file formats and use Big Lake across it to secure it, to modify data consistently, to have super fast access, and to even then use BigQuery for SQL or open source processing engine on top of it. It is the ultimate simplification.
Yeah, couldn't agree more. And when we talk about Google's Data Cloud, we're always talking about simplicity and how we make things as seamless as possible for a lot of our customers, right? And this is just one step ahead in getting to do that.
That's exactly right, yeah.
Yeah. All right, next question up. This is from Lahari. Lahari, thank you so much for asking this question. Cloud SQL versus BigQuery, what is the difference? This is a great question because, when we think about Cloud SQL and BigQuery, both of them are relational databases. But I think what's unique about them is, Cloud SQL is an operational database that's fully managed, and it's for running MySQL, Postgres, and SQL Server workloads. And we think about BigQuery. BigQuery is actually an analytical system, right? Running all kinds of analytical queries, right? Blazing fast speeds, helps you analyze your data. And so you'll hear a lot of us talking about BigQuery, and it's, the heart of our data cloud.
And actually what you see with many customers, they're using both together. Like Anita said, they run their transactions on Cloud SQL, they connect it to BigQuery as their system of intelligence, if you will, and then they drive a really data-rich experience with transactions and analytics.
Yep, couldn't agree more. And actually what's really cool about the two systems is that we actually support federation between both of them, right? Which means you're actually getting, again, that best of both worlds, and again, that simplicity, right?
Right on. All
right. Okay, the next question we have here is from Venu Gopalan, and hopefully I said this name correctly. My apologies if I missed this, but how is Big Lake different from BigQuery Omni, and where can I get details, Garrett?
Hey, I love that question because it is really talking about two of our biggest innovations. BigQuery Omni is our multi-cloud support for BigQuery. Basically, what it allows you to do is to break the barrier between different clouds and federate analytics across Google Cloud, AWS, and Azure. So it is really a cross-cloud analytical platform offering on top of BigQuery. Big Lake basically takes a different part of the data problem, if you will. Big Lake is really made now to unify data warehouses and data lakes. And the idea is that we take the foundational layer of BigQuery and we extend it to support data lakes as well. And that means that basically you can use any open source file format, Apache Iceberg, for instance, and you can use Big Lake now to, as I was saying earlier, secure it, run DML statements on top of it, run open source processing engines on top of that. And there is a good wrinkle that you catched up upon. Big Lake is not only limited to GCS. So you can also now basically take Big Lake data management and extend it to other clouds as well.
Yep.
And that, in summary, basically means that BigQuery Omni is the big compute layer. It's running queries across cloud. And Big Lake is the base layer, which allows you now to manage data lakes across clouds.
Yep, that is true. Nicely done there, Garrett. All right, this is another question. Do you need to be a data scientist or ML expert to use AI on Google Cloud? I think the answer there is no. Isn't that right?
Well, Here is one of the key innovations that I think is important for us to highlight that Google has brought to the market. Slightly outside of what we covered in a keynote, but worthwhile addressing. The key to data science and machine learning actually is democratizing the access to it.
Yep.
And when you look at areas where we have innovated at Google, it is around AutoML, basically automating automation, so that citizen data scientists, business analysts, basically everyone working with data can train, build, and deploy models without being a deep data scientists themselves. And of course, we have expert tooling in Vertex AI for data scientists as well.
Exactly. And also, let's not forget BigQuery ML too, right? The idea of using simple and standard SQL to be able to run machine learning models
exactly
on your BigQuery data. I mean, again, the idea of simplicity and giving folks the tools that they're very familiar with to actually get their work started. So it goes a long way. All right, this next question is from Shang Yi. Where can I find examples showing how Spark works with BigQuery and other Google Cloud resources? And this is a great question. The latest innovations help to make Spark a big class experience across Google Cloud. And so check out the Spark on Google Cloud website for more resources, and that's a good place to get started. And also something else I want to call out is that, when you start to look at trainings and, some of the hands-on labs, there's a lot of learning, including certification. So those are always good places to get your knowledge on. All right, next question from Anoop. Can you provide some insight into what tools are used for the ingestion layer in GCP data analytics platform? Garrett, this is a good one for you.
Anoop, great question. And the answer is so many and so much choice.
Yes.
Because basically we approach data with an open mindset around the partner community. And we are partnering very closely with a lot of data integration and data ingestion providers. So chances are pretty high that the tools that you are using already, be it Informatica, be it Fivetran, be it so many others, they are already supported and even certified for the usage on GCP together with BigQuery. There is even a program that we run, which is called Google Cloud Ready BigQuery, which basically makes sure that many of the data integration products that you are using, they meet all of the functional and all of the interoperability requirements together with BigQuery. Now, having said that, there is also a set of first-party services that we are offering on GCP and for BigQuery. And now it really depends on what you are looking for. There are simple ingestion services for files with the data transfer service, and it allows you to easily move data right into BigQuery. And we have more advanced services such Cloud Data Fusion, where you can build complex data pipelines and orchestrate a more complicated set of transformations and a heterogeneous data landscape. So the choice is really yours, and I encourage you to go on our website where you can find not only our first-party solutions, but also great references and examples for all of the partners.
Yep, that is true. And we talked a lot about, partners and all the work we're doing to innovate. And so at this Data Cloud Summit, we've unveiled a lot of, partnerships across, all incredible partners, again, to help you, bring that data onto the platform and make it seamless and easy for you to actually get started analyzing your data, right? And making those big business decisions. So, all right, from June. June, thank you for this question. How could I start to learn using BigQuery? Fantastic question. I think if there's one place I will send you is hands-on labs. That's a good place to start. I would say BigQuery free trials, and there's actually a free tier option for you. So that's another good place to start. Again, I talked a little bit about, training, certifications. Those are all fantastic places to start. And so I would say go to cloud.google.com/BigQuery, and we have tons of materials there to get you going on BigQuery.
Yeah, start definitely with the free trial, right?
Yes, free trial.
That is one of the most awesome offerings that you can basically get hands-on with BigQuery. You can use code examples. There is so much in terms of public and open data sets right available in BigQuery that practically you just need to sign up. And then you can just, making your first experiences with BigQuery right in the product.
And what's interesting is I do remember when, we were getting all these questions from a lot of customers and talking about how do I quickly get started with BigQuery, right? And so we talked about this free tier option where you actually can get started with BigQuery without a credit card. And this was big. It democratized how folks were thinking about BigQuery. So definitely a good place to start. Again, check out all those resources on cloud.google.com. All right. So the next question we have here is from Pranesh. What exactly What exactly can I do with Vertex AI? I believe that's the question.
It is a great question and, Arpanesh, a fairly broad question, because Vertex AI actually is a complete machine learning platform, which basically means that it covers the full machine learning lifecycle.
Exactly.
It starts from acquiring and managing data, identifying features, training, testing, and deploying models, machine learning operations, which basically means generating web service endpoints for them so you can use them for inference and monitor how they behave in the production environment directly. So basically, Vertex AI is basically what you need if you want to do machine learning at any scale. And I would really encourage you, if you want to learn more, to go on the Google Cloud website. There is great materials on Vertex AI, and there are great code labs and great examples that really show you what the full machine learning lifecycle actually looks like.
Yep, couldn't agree more. All right, this next question is from Trivikram. How do you manage ML workloads with the help of BigQuery and databases? And I think we've touched a little bit on this one, right? I think we've talked a little bit about BigQuery ML. We've talked about Vertex AI. Anything else you can think of here, Garrett?
Asked me to talk about data. So
right, there you go.
I think it's a great question. And it gives us a chance to address one of the biggest hindrances actually in machine learning. There is this common saying that every AI project is a data project.
It is a data project.
In disguise.
You have to have your data right.
That's exactly right. So what we have done with BigQuery machine learning is actually that we embed Vertex AI, what we just talked about, right into BigQuery. And that means that you can basically invoke Vertex AI models directly from your SQL environment, directly from the context of your data, which means that practically you write only SQL to acquire data, to create models, and to support the right data structures into it. And then the coolest part is you can also invoke these models right from BigQuery again, which means that if you want to do analytics now using a machine learning model, again, in the context of where you are in BigQuery, you just write SQL, you invoke the models, and you get all of the inference, all of the classification, all of the regression models directly evaluated. And I think that is sheer beauty and ultimate simplicity.
Can't agree more. And you know what's interesting too is we talked a little bit about the Vertex AI Workbench, right, which is a new innovation we announced here. I believe product was going GA, but yes, learn more there and figure out all the tools available to you. But we have lots of tools again to meet you where you are. All right, this next question is from Elling. What is the future of Data Studio? Are there still going to be free BI capabilities for SMBs? It's a good question because we talked a little bit about this one.
We did, and it is a lovely question.
Yes.
Because it gives us a chance to say in public in this forum that 100% yes. We are such big fans of Data Studio.
Oh yes.
It has millions of users today. It has millions of dashboards built, and we are so proud that what all of you are really driving in terms of BI and data visualization with Data Studio today already. So when we talk about Big BI and the unification of Data Studio and Looker, we just talk about it, giving it more capabilities, making it better, and making it part of a bigger BI strategy. But for all of you, SMBs and the ones who are using Data Studio today for free, please continue doing it. So we love it. And in fact, we want to see much more of it.
Yes, and we talked about the fact that Data Studio has millions of users. I think the product kind of speaks for itself, right?
That's exactly right.
Exactly, that whole self-service ability is just fantastic. All right, the next question we have here is from Manpreet. What solution or tool do you recommend for data modeling? And I think here we would talk a little bit about BigQuery, Dataflow, Dataplex, some of those core capabilities on Data Cloud platform.
Yeah, and it's one of those questions you cannot possibly answer in just a few seconds.
Yes.
So, all of that is pre-texted with, please, go to Google Cloud on our website and, inform yourself because there is so much good information. But on a very high level, we are strongly believers in SQL and SQL-based modeling. It's an open standard. We are committed to it. And we intentionally try to keep things simple for all of you, which means that if you are on BigQuery, basically your modeling language and the environment is given by SQL. And if you look at the other products like Dataflow and Cloud Data Fusion, they have kind of a different paradigm because you're more looking at data pipelines and data flow. So the one is data at rest, the other one is data movement. And in those environments, we have special graph modeling and special templates for you to basically model your data pipelines.
Agreed. All right. Let's jump on to the next question here from Brian. I think this is a fantastic question. Are there tools in place to allow regular business users to access data ad hoc without needing a task an analyst? I think we talked a little bit about, not a little bit, a lot about Data Studio and also integrations with connected sheets, right? So if you're thinking about continuing to use all the knowledge you have with sheets, connected sheets actually is, works really well with BigQuery, right? Export data, connected the two of them, and there you go. Just use your standard, sheets formulas, and you're good to go.
And there is one more thing that I think you should be considering, Brian. I think we talked about it in the keynote. Looker has this beautiful semantic model, which basically lets, someone to build reusable data models, for someone then to be used in analytics. And actually what that means in terms of outcomes is that we see an immense reduction in the reliance on technical teams. So basically that means that, if you're seeking to have secure, governed, trusted, and fast data discovery, but self-serve, Looker, and especially with Data Studio together, is a fantastic environment for you.
Yes, and am I, letting the cat out of the bag when I talk about, Project Big BI, right? You're getting the best of both worlds. Again, we're thinking through, again, all our users and how they're leveraging all the solutions we put out there. But when we talk about, Data Studio and Looker coming together, again, it's a win-win. All right, so can't believe we're in our final question, Gary, because this was so much fun.
Time flies.
Anyways, I know it does when you're having fun. So this last question is, what is the difference between Dataproc and Big Lake?
All right, a big question.
We've talked a lot about Big Lake already, so.
So let's start with Dataproc, right?
Yes.
So Dataproc is a set of managed and highly scalable open source processing engines. It's like, Spark, Fling, Presto, and many, many more services around that. BigQuery, we talked about it too, is Google's completely serverless and highly differentiated data warehousing offering. So what Big Lake now does is basically unifying both worlds by extending out BigQuery's base layer, right? All of the, the file access, file modifications, performance acceleration, data management, and extends that to data lakes. To file stores and formats like Apache Iceberg.
Exactly.
And that means now for Dataproc and BigQuery that on top of Big Lake, you can use Dataproc and open source processing engines, or you can use BigQuery SQL for warehousing and ultra-fast SQL execution on the same base layer.
Awesome. Well, thank you so much. Unfortunately, we're out of time. Thanks so much for participating in this Q&A and for joining us today. Be sure to stick around now as various breakouts will begin. These sessions will cover all things data across Google Cloud Portfolio. And to wrap things up today, we'll have an amazing demo happening at 11:45 a.m. Pacific time. Thanks again for joining us. This was fantastic.
And bye.
Bye.
Hello, everyone. I'm Sudhir Hasbe, and I'm going to talk to you today about unlocking innovation with limitless data. So with that, if you look at organizations across the globe, 68% of organizations today are not able to realize tangible and measurable value out of their data. And it's a huge problem in the industry. And there are three key reasons or three key things that are happening in the organizations because of which this metric is true. Number one challenge that organizations face is data is big and it's multi-format. And so the size of data is growing within organizations. And as this grows, you have structured and unstructured data, you have real-time streams and at-rest or batch data, you have across multiple clouds that this data is actually getting distributed. The second big challenge is this data requires different kinds of processing. Traditionally, you could put some of this data into a data warehouse. You could basically go ahead and run some SQL queries and build some dashboards, and that was enough. But that's not true anymore. You want to use different kinds of tools and capabilities on top of this kind of data. You want to run machine learning and AI. You want to do streaming analytics. You want to do data-driven applications on top of it. And so these kinds of workloads are increasing within organizations. And finally, and most importantly, data needs to reach to more users and provide insights to more and more people in the organization so everybody can better decisions. And so as more and more users are growing that want access to insights, that is becoming a critical part of the whole organization. And this is where data is becoming mission critical in organizations, and that is a big challenge for everybody. And so as we think about future, the future is moving towards this concept of having limitless data ecosystem that can be used to drive innovation. Innovation is finally going to be driven through data and AI, and that requires these three key aspects: access to limitless data within the organization, access to limitless workloads, not just SQL, but machine learning and streaming and various different kinds of workloads, and then limitless reach of this data and insights to people within the organization. And at Google, we are a data and analytics company. We basically, our whole goal is to simplify the world's data. We basically have around 11 or 12 products that have more than billion monthly active users. And we're collecting different kinds of data, simplifying it, using machine learning and AI to provide experiences on top of this kind of data. And what we are doing in Google Cloud is bring all of the portfolio of capabilities that we have built over the last 20 plus years and make it accessible to enterprises through something we call Google's Data Cloud. And Google's Data Cloud is not limited to analytics or just machine learning. It expands end-to-end across all the different kinds of workloads that you may have. It includes the whole platform that is highly secure. It includes different kinds of processing capabilities you'll need, whether it's batch or stream. It includes your capabilities around operational or analytical workloads. And so any kind of workload can be run on our platform and in our data cloud. Similarly, you can have any kind of data, structured, unstructured, semi-structured, and similarly, any kind of user or any kind of persona that can access that particular data sets and insights. And similarly, that should drive any innovation that you want to drive within your organization. And this is exactly what we are seeing across the globe. Now we have more than 700 partners that have built applications and solutions on top of our data cloud. And similarly, we have hundreds of technology partners that are building and extending our capabilities, whether it's in form of providing data ingestion services, governance capability, maybe better integration for AI and ML, companies like Data IQ, and all of these. So all these partners are extending our platform to give you better solutions. Today, I wanted to invite my friend Sanjay from Exabeam to share how they are using Google's Data Cloud to build the next generation solutions. Sanjay, welcome to the conference. And how about you introduce yourself and share your story?
Thanks, Sudeep. Hi, everyone. My name is Sanjay Chaudhary. I'm VP of Product Management at Exabeam. I'm really excited about sharing my journey partnering with Google Data Cloud team, which has helped us deliver an unprecedented scale cybersecurity platform. Now, last year, we evaluated pretty much all big data analytics and off-the-shelf vendors as we were thinking about a limitless scale cybersecurity platform to support unprecedented growth story. And one thing I really liked about the Google Data Cloud story is that Google gives us end-to-end solutions for all stages of our cybersecurity data platform lifecycle, starting from limitless storage, limitless ingestion, limitless processing, limitless analysis. So this helps us not have a situation where some components of platform can scale, but others cannot. And with this new platform, we are able to deliver features faster, provide extremely high reliability without increasing our cost to onboard more and more people to support the platform. As a security analytics company, we process a lot of data to drive insights. In fact, we collect data from 500 plus security vendors. Each incoming security event gets evaluated across 100 plus features to drive threat detection insights. Google's Data Cloud offering allows us to process millions of events per tenant per second. And this has significantly helped us offer capabilities with limitless analytics. Our industry still have people using technologies like Spark, Kafka, Hadoop, or Pulsar for data processing. This is a game changer for us. And I'm really excited about this partnership because it further advances our capabilities in security analytics. Unlike our peers who like to separate hot data, warm data, cold data for search and detections, our partnership with GCP BigQuery allowed us to store all multi-year data in one place, and our engineering team's ability to build strong modeling techniques allows us to search all of that data in a few seconds. So when you're dealing with a cybersecurity threat, which is in a stealth mode in your environment, you can still search multi-year data in seconds. As I mentioned, with the unprecedented demand, we were able to bring a security data platform with limitless scale in months instead of, let's say, years or quarters. Our ability to offer multi-year data and detection is going to significantly help us in the security analytics space. Our ability to offer search and detection on multi-year data will help us separate the traditional SIM silos of storing separate data in hot, cold, and warm storage, and position us strongly in the SIM market. Last but not the least, the ability to deliver nice dashboards, reports to our SOC teams will allow us to modernize our customer SOC experience. I'm very excited about this partnership, and I'm very thankful for Sudhir and Google Data Cloud team for inviting me here. We will be publishing some more blogs around our journey with Google Data Cloud. Thank you so much. Back to you, Sudhir.
Thank you, Sanjay. Thanks a lot for sharing the whole story. And as you were talking about ability for BigQuery to store these hundreds of petabytes of data, provide an integrated search across all different types of data that you may have, is pretty compelling for a lot of organizations. BigQuery, our largest customer now, has almost an exabyte of data in BigQuery. It's super exciting to see how organizations are able to break these data silos, have all their data in a one single system, and run different kinds of workloads on top of it, whether it's search, whether it's time series analysis, whether it is natural language kind of processing, and all of these different types of workloads. But next I wanted to talk about is limitless data. And as I mentioned, BigQuery is enabling organizations to have this massive scale data sets that you can store. And then you can have this, whether they're structured, unstructured, semi-structured, all different types of data. But it's not just about data that's in your organization. One of the key trends across the industry that we are seeing is this ability for organizations to share information between each other so that you can drive innovation that crosses organizational boundaries. And we are already seeing this. We have, last we highlighted, we had 3,500 plus organizations sharing more than 275 petabytes of data on a weekly basis in BigQuery across organizations. And so to enhance that capability in BigQuery, we now are announcing preview of Analytics Hub. Analytics Hub is our data exchange platform that allows organizations to securely share information across them and innovate on top of it. We are also working with organizations like Crux to bring in a lot more commercial data sets into the platform. You should have access to roughly 250 plus data sets at the get-go in preview, and we will multiply that by the time we go GA later in the year. The second thing is cross-organizational data sharing is one aspect, but one of the other challenges organizations have is their data is actually getting distributed across multiple different data providers, data clouds, and all of that. And so today we are announcing preview of something called Big Lake. Big Lake is a multi-cloud data lake service that we are making available for our customers, starting with support for data in GCS, extending that to S3 and other object stores, when all of this data will be accessible to various different engines through a single API that allows them to go ahead and run different workloads. And so this will basically be a game changer over a period of time. One of the things, I want to go more in details of what capabilities we'll provide, but the whole idea is now you can have an integrated lakehouse that can actually span multiple different cloud environments. And that's where we believe we can go ahead and change the game. And on top of that, you will have unified governance and management through Dataplex, which is our cross-cloud data management capability that we are going to work on. It includes data cataloging, it includes metadata management and all that. We'll go more in details of that. But a little bit about how I think about Big Lake and where does it come from. So if you look at BigQuery and BigQuery's architecture, we are the first large-scale analytical engine to go ahead and have a compute and storage separation 10 years or 11 years back when we launched it. We basically had all of our storage sitting in Colossus, and we had our query engine that runs on top of it, and we have Capacitor, which is our own file format on it. That's how we separated and built the system. A couple of years back, we realized organizations wanted to run various different types of open source engine on top of the same data. And we made that happen through a BigQuery storage API, which was supporting Arrow as the format, and everything ran on top of it, and various engines could run. But all the data was still, in that case, stored in BigQuery's storage system, which was based on Capacitor. It's our internal format, highly optimized storage capabilities and analytical capabilities, and also streaming warehouse as part of our Vortex system. What we are actually doing is taking all the key innovations over the last 10 years and now extending that on our cloud storage system, so GCS, and your files and or your data within GCS can be in Parquet, JSON, all open source formats. We will support that. So anything that was possible on BigQuery storage and Capacitor will now be available to data in GCS with open formats. More importantly, we are going to expose these capabilities in table formats that are going to be possible. So we will start with Iceberg, and in future, we may support various different other formats too, like Delta. But to begin with, Lakehouse, completely managed tables with Iceberg format, running various different engines on top of it. And at the base of it, you still have your Parquet ORC files, and all of this, it will get the BigQuery treatment. So all of the BigQuery capabilities will start flowing for all of these formats. I think it's going to be game changer how we are bringing our innovations from BigQuery into the open source world. So we talked about limitless data. Let's switch gears and talk about limitless workloads. As organizations are seeing various different types of workloads getting importance, Spark is one of the most important engines for various organizations that we work with. And we recently launched our first serverless Spark offering that allows you to go ahead and just submit jobs and execute jobs. One of the few things that we are doing is we are making this capability pervasive across all of our existing experiences. So we basically are integrating that with our notebooks. I will talk a bit about it. We are also integrating that with BigQuery. Now, if you go in BigQuery, you have a PySpark editor. You can start writing your Spark code against the BigQuery data out of the box. And then you basically have ability to go ahead and run that Spark with our serverless offering. You can run it on GCE, or you can also run it on GKE, which is our Kubernetes-based offering. So you have complete flexibility of how you run your Spark workloads on top of GCP. Addition to that, we are also announcing GA for Dataflow Prime. In data processing world, one of the biggest challenges that exist is whenever you try to do distributed processing, the compute tier is always same. So you have a large pipeline. Some steps in the pipeline may require a lot of memory because high memory jobs are being done. But normally horizontal scaling means you give the same hardware to everything. What we have learned in Google is that is not the most optimum way of actually running these pipelines and workloads. And Dataflow is changing the game there and allowing you to go ahead and have automatic vertical auto scaling. So if some tasks require bigger machines, we will automatically pick it. But if not required, we will go down to the base machines that are required. And that way, the largest of our customers are seeing a lot of benefits and savings because now you don't have to run the full pipeline with the same kind of a hardware. So this is going to be really amazing for organizations that are doing real-time streaming analytics or large-scale batch analysis on their data. And one of the other things that we are adding with that is the smart diagnostics. We have an SLO-based execution model where you define how long you want to go ahead and wait for that pipeline to run, and we can optimize what kind of hardware we use and when we can finish the jobs and all. So this is a game changer. I think we are seeing a lot of tremendous interest in this space. The next thing that I want to talk about is one of the biggest challenges when I talk to CIOs and CDOs across the globe is around governance. And we are announcing Dataplex GA. We announced it like a few weeks back. It's basically one single framework for you to have intelligent data management, governance, discovery. And one of the other things we are doing is we have a lot of investment in data cataloging. And so data catalog now will be part of the overall Dataplex vision for us. And so Dataplex will include catalog, discovery, logical organization of your data, security, so you can secure all of your data across various different data stores that you have through Big Lake that we announced earlier. And all of the systems, everything will come together into a single framework for you to manage centrally. And on top of that, we are also announcing preview of data lineage capability as part of Dataplex and our cataloging capability. So any lineage from BigQuery is already automated. So all your data, all the processing, all the changes you do in BigQuery, all the lineage will be automatically extracted and stored in the catalog. You'll be able to discover it. You'll be able to look at what's changing. You can audit it. And we will start using that for various different capabilities to provide you better data quality over time and all. So super excited about the whole data governance, lineage tracking, and all of that. Finally, I want to talk about limitless reach. All the data in the world together, all the different kinds of workloads is great, but it only adds value when everyone in the organization can get the right data at the right time to make the right decision. So in that front, super excited to announce that we basically a few months back moved Data Studio, which was part of our ads business, back into GCP. And it is going to be a first-class service available in GCP going forward. A lot of organizations use Data Studio for self-service BI, and Looker, which is our governed BI model, where you can define your semantic models. We're bringing all of these together into a single BI offering, wherein you can have governed BI, you can define your semantic models, you can use those semantic models from Looker experiences, but also Data Studio experiences. So combined, all of this allows you to go ahead and have a strategy where you centralize metrics where you need to, but decentralize visualization where you don't need to go ahead and centralize things. And that combination is what makes organizations successful. Super excited about this. In addition to that, we are announcing GA for our BI engine capability. We built BI engine actually in partnership with the Data Studio team to accelerate BI workloads. Now, we later announced it to go ahead and support various different tools. With this GA now, same acceleration capability in BigQuery for BI workloads is available for all our BI partners. This includes Tableau, includes Power BI, includes Click, Domo, Sisense. All of our partners will benefit with this acceleration. In addition to that, we also have our own properties, whether it's Data Studio, Connected Sheet, Looker, as well as you can build rich data apps on top of Looker's core capabilities and data APIs and all. In addition to that, we are also putting together various different aspects of the components to accelerate data analytics within organizations. We started last year with the design patterns. We've launched roughly 38 design patterns. We plan to do another 150 this year. And design patterns are ability to go ahead and enable specific use cases within organizations where you can go from start to finish within few weeks or within few days rather than months. Data flow templates are a great way. If you want to move data from A to B, it pops up to BigQuery or pops up to Elastic, you can go ahead and use data flow templates and, like, without writing a single line of code, accelerate that. In addition to that, we have our migration services, and we are super excited about the security blueprint, which allows you to go ahead and out of the box set up the whole BigQuery environment, including DLP integration and all. With that, I want to go ahead and thank you all for being here, and I want you to start your Data Cloud journey today. You have various different opportunities here. You can sign up for BigQuery Sandbox. It's ability for you to go ahead and use BigQuery without even a credit card. You can discover the industry solutions we have built, and you can uncover various stories on how other organizations are benefiting from the Data Cloud. Thank you, everyone. Thanks for spending time with us today.
Welcome to this session where we will dive into a conversation on how Deloitte used its business transformation expertise and its technical might to help a multinational bank reach their business goals using Google Cloud's innovative services for data and cloud infrastructure. It's not often we get the inside track on the cloud transformation of a globally recognized world-class bank, but today we do for ING Group, Dutch multinational banking and financial services corporation. In 2020, the company experienced target operating model challenges and no global streamlined approach to data and technical cloud readiness. Moving the business to the cloud was the best and right way forward. My name is Simon Brown, and I lead Google's smart analytics business with our GSI partners. And with me today are two insiders, Kerem Tomak, ING Group's Global Chief Analytics Officer, and Sandra Bauer, partner at Deloitte. Kerem, Sandra, welcome.
Hi, Simon. Great to be here.
Hi, Simon. Good to be here.
Thank you. So, Kerem, let's jump right in. You joined the company early in 2021, and you immediately set to work on this significant transformation. What were the three biggest hurdles, let's call them mountains, that you had to overcome?
Simon, it was basically the three buckets that I always pay attention to when I build organizations. It's people, process, technology. And people part is the hardest part because we're talking about changing a culture of an organization, making the organization a bit more mature and also more aligned with the business. I am a strong believer in making analytics organizations strategic partners of businesses and business counterparts that we work with and that we bring value. And that only is possible by making sure the right skills are in place to engage with the business, and that end-to-end delivery is guaranteed by all the skills that we have in analytics, from technology side all the way to actual delivery to the business solution for the stakeholders. And the second piece is the process. We have to be safe, secure, and compliant for everything we do as a bank. And so that applies to everything we do in analytics organization. When we build processes that is going to scale, we first make sure that all the guidelines and guardrails are in place to get to a scalable analytics operation with a safe and compliant operation in place. And so that was also what we did when we started to build Bridge to the cloud with use cases that we started working on, making sure that the data analytics components are safe, secure, and compliant, and also abiding by all the regulations and rules that we have to abide by as a bank in Europe. And the final component is technology. For that, we started with looking at all the technology solutions in place for analytics and making sure that we are consolidating to the platforms and systems that we are going to use for exploration and then in production. And part of the operation obviously included to build the bridges from the production environments into cloud, Google Cloud, so that we are able to scale using compute power of the cloud for the use cases we deploy both on-prem and then into the cloud.
Okay, awesome. Sandra, you were part of this project from start to finish, and you're so deeply involved in ING Group's future. Hearing those three mountains in 2021, what did Deloitte immediately see as the way forward?
Well, being in analytics for most of my life, we do feel that we need to go from strategy to implementation and then using technology. Deloitte provides an insight-driven organization framework that actually focuses on 5 pillars: strategy, people, processes, data, and technology. So what we did a maturity assessment with ING. They didn't start from scratch, but they really wanted to build their ambition going forward and put that into action. And based on those 4 pillars, we actually developed go-to use cases and capabilities that need to be developed in those areas. And one of the main focuses, of course, was building up the technology to actually help them be faster in the go-to markets going forward. So becoming an insight-driven organization encompasses of a lot of things that need to be established at the same time, and it just must move forward. And that's actually leveraging the data sets going forward a little bit more proactively than just having them sit in silos. So that was one of the approaches that we used.
Okay. So, Karen, we chatted beforehand and you shared that sandboxing and proofs of concept were pivotal to getting your board on side. But why is that? And what did the process of developing both look like?
Thanks, Simon. Yeah, that's essentially an absolute must, that we have to get buy-in from the business and the board, top down, obviously, and right and left, the different parts of the organization. So I think the success of any analytics operation is starting from how are we capturing the business requirements and questions we need to answer with analytics, and that in return, the POCs that we are building, how well are they bringing value or actually creating a glimpse into the future value that will be created if we put the POC results into production. And obviously, along the way, we co-create with the business to make sure that we are capturing all the nuances, requirements, and their daily in and outs of how they are running their business. We are analytics on the second line. We need to make sure that we are talking closely with the first line business to understand their needs. And this is the only way, I believe, going forward, that analytics can bring value. And finally, once the POCs are built, we also obviously look at, did the POC capture the right question and right solution, but also are the KPIs directing us towards the value that will be captured if we build them in production. If all of those are answered as yes, and the business says this is yes, what we were looking for, only then we put the solutions in production. And obviously, before we do that, we also have to go to our board members, which I'm reporting into, to make sure that they have visibility and transparency into what analytics is driving for the bank, because they are heavily vested into the success of analytics, because they see the value in the analytics for the bank's future. And so, we follow the standard route of, here's the proof points, and here's the buy-in, and the solution is there to solve a business problem, and then we go forward.
Fantastic. So Sandra, walk us through marrying the best of Google Cloud and Deloitte to move ING Group to this new place. What does that look like?
Well, based on the good alliance that we have between Deloitte and Google Cloud, which is actually not only based on trust, but it's also built on a motto that we developed together. It's challenge with competence and convince with culture. So we're marrying both worlds, coming from Deloitte with a clear business perspective, but with also deep technology expertise, and marrying that with the innovation and IML capabilities of Google as the key player in that area. And Google Cloud is definitely the key player. And with us being the fourth-time partner of the year for Google, that really brings to the table the best of both worlds. So we're not only helping implementing new use cases and proof of concepts, but we also help with legal requirements that our clients are facing. ING is operating in 40 different countries. So we do have legal experts, for example, looking into GDPR issues, but we also help them in establishing the governance around what actually can go to the cloud securely. And we have a risk advisory practice, for example, that helps us with that. We also have a cybersecurity practice. And those different areas need to be on the table together with the client to help them actually streamline the approaches that they want to use to move securely into cloud. And that's one of the key success factors that we as both organizations have and bring it to the table to our clients going forward. So that's really cool to have.
Okay, thank you. So that's all we have time for today. I'd like to thank you both for working with us to solve these problems. I'd like to thank you both for joining us for the Data Summit, and I wish you the best for the rest of the day.
Thank you.
Thank you, Simon.
Microchips are used in all kinds of devices. Chances are that if you look at the devices around you, your phone, your car, your laptop, they contain chips that have been processed on ASML machines. All major chip manufacturers in the world are our customers. Our customers expect nanometer precision. It means that a misalignment of a handful of atoms to the left or to the right make a difference between success and failure. Our on-prem environment was not able to scale fast enough to the volume of data we had to process, to the complexity of the experiments we needed to run. We chose Google Cloud because we needed an environment where we could design, we could build, we could validate solutions that combine extremely complex physics models and machine learning by enabling super fast experimentation and deployment of solutions. Moving to Google Cloud helped us shorten our learning cycle to the point that we could turn months of research and development into weeks. This is how you enable engineers to innovate faster and make customers happy. Because at the end of the day, technology doesn't build product, people do. Our collaboration with Google Cloud has always been about making it possible together with what is available today and what can be available tomorrow.
Hey everyone, thank you for joining us for the 2022 Google Data Cloud Summit. I'm Andy Goodmans, General Manager and VP of Engineering for Databases at Cloud. I'll be joined in this session by Bala Natarajan, Senior Director, Data Infrastructure and Cloud Engineering at PayPal. This session will cover some exciting new product announcements, some of our recent innovations, and our key focus areas for Google Cloud Databases. Google Cloud Databases are proven to run planet-scale workloads, from the most demanding workloads of our enterprise customers to Google services with more than 1 billion users around the globe. To give you a sense for the scale at which our databases operate, Spanner processes over 2 billion requests per second at peak. This is unheard of for a relational database service. Bigtable, our fully managed NoSQL database, processes over 5 billion requests per second at peak. Firestore is our serverless, mobile-optimized document database, powering applications with more than 750 million monthly active users. So this demonstrates the scale of the workloads that our databases support. Our databases help our customers modernize their apps and unlock the value of their data across the GCP ecosystem. For example, more than 650,000 Google Kubernetes Engine pods connect to Cloud SQL. And BigQuery users query over 125 petabytes of data in Cloud SQL on average per month. We offer best-in-class databases for always-on applications with global reach and unlimited scale. Google Cloud is committed to open source and open standards. We offer managed services that are fully compatible with the most popular open source engines such as MySQL, Postgres, and Redis, or third-party proprietary databases such as Oracle and SQL Server. We manage the complexity of running your databases so that they are simple to use and operate and make application development faster and easier for you. Leading organizations in all regions and industries have placed their trust in our databases. And our databases remain one of the fastest growing segments of Google Cloud. The reason for this strong adoption is that we have a relentless focus on addressing enterprise customer needs. Key areas you have told us you really care about: reliability and availability, security and governance, observability so engineers can self-help and root cause efficiently, making migrations easier and efficient, pre-integrating with other services such as analytics and AI and ML so you don't have to take care of the plumbing yourself. Lastly, continuing to help you better govern spend and make continuous improvements in price performance. I will briefly walk you through each of these areas and provide you an update on the progress we have made in each. For reliability and availability, our transformative databases, Spanner, Bigtable, and Firestore, offer an industry-leading availability SLA of 5 nines. They also offer automatic sharding, zero-touch global replication, and no maintenance downtime. Cloud SQL maintenance is on average 80% shorter than it was 12 months ago. In fact, Cloud SQL's average maintenance downtime is now shorter than that of Amazon RDS and Azure databases, according to figures published in online documentation as of August 2021. Coupled with controls such as maintenance denied period and advanced notification, Cloud SQL is an industry leader in this space. With the recent addition of SQL Server cross-region replicas, Cloud SQL provides customers with multi-region scalability and disaster recovery options. For security and governance, we have standardized authentication and authorization in databases with IAM. For Cloud SQL for SQL Server, we've enabled cross-project integration to authenticate via managed Microsoft Active Directory. We continue to invest in more rigorous controls, such as customer-managed encryption keys, which provides customers complete encryption control of instance data and backups, as well as the ability to rotate keys on their own schedule. Security and governance is a huge focus area for us. For highly integrated, customers asked us for a solution to replicate and synchronize data across heterogeneous databases and applications in order to support real-time analytics, database replication, and event-driven architectures. DataStream is a serverless change data capture service, which became generally available late last year. With DataStream, you can easily and seamlessly deliver change data streams from your Oracle and MySQL databases into Google Cloud services such as BigQuery, Cloud SQL, Google Cloud Storage, and Spanner. And today we are thrilled to announce that Spanner Change Streams is coming this quarter. Spanner Change Streams enable Spanner customers to track changes within their databases based on a defined scope and to easily access and integrate this data with other systems. With Spanner Change Streams, you can track changes on an entire database, a set of tables, or a set of columns in a database. This means customers can easily replicate database changes to BigQuery for analytics, trigger downstream application behavior from changes to the database, or capture database changes for archival or long-term storage purposes. Now let's see a short demo of Spanner Change Streams.
In today's demo, we'll look at a sample inventory application powered by Cloud Spanner and see how Change Streams allows you to seamlessly stream that data to BigQuery in near real time. Let's start by looking at the demo environment. As customers purchase items and inventory status changes in Spanner, the application inserts into this inventory ledger table. Our goal is to replicate these changes over to BigQuery for analytics. So let's go ahead and create a change stream. Creating a change stream is super easy. You just use DDL. That means all your existing workflows are supported. This change stream will track all changes in the inventory ledger table in Spanner so that we can stream those out to BigQuery. With a retention period of 1 to 7 days, you are in control of how long the changes are being kept in the stream. In this environment, there's already a high QPS workload on the inventory database. Let's manually insert a row into the table here. To simulate a restock of 500 avocados, we will follow along these avocados on their journey to BigQuery. To read and process changes out of change streams, you can use one of the Google-provided open source data flow connectors, create your own connector based on our sample code, or use the underlying APIs directly. You have the full flexibility. For this demo, we've already deployed a pipeline based on our turnkey Spanner to BigQuery data flow template. Over in BigQuery, we can see that the connector has already replicated the relevant schema from Spanner and has streamed the changes into the corresponding table. So let's find our 500 avocados that we added to the inventory in Spanner earlier. Oh, look, there they are. Change Streams has streamed out the changes and the data is already available in BigQuery. With Change Streams, your Spanner data follows you wherever you need it at scale. Whether it's for analytics with BigQuery, to trigger downstream applications, or for compliance and archiving use cases. Thank you, and back to Andy.
Wow, that was an awesome demo. I am so excited about Spanner Change Streams. For financial governance, we believe that getting the best price in the cloud shouldn't require sophisticated forecasting models. Our committed use discounts reward your steady state, predictable usage in a way that's easy to use and can accommodate changes in your database environment. These committed use discounts are flexible. No upfront payments are required. These are available for and shared between MySQL, Postgres, and SQL Server instances, and they're fully transferable between machine sizes. So really the most flexible committed use discounts. We recently launched Bigtable Autoscaling, so you can automatically add or remove capacity in response to changing demands of your workloads, and only pay for the capacity you need. It also reduces your management overhead, so you can spend more time on your business and less time managing your infrastructure. We recently introduced Cloud SQL Cost Recommenders with Active Assist that empowers developers to better manage costs. It helps you detect idle instances, right-size over-provisioned instances, and leverage committed use discounts. So we are truly doing everything to make Cloud SQL and your experience with GCP more affordable. As wonderful and unique as Spanner is, it wasn't the most accessible database for developers. We wanted developers to be able to start small so they could design their applications for success from the get-go. To this end, we recently introduced more granular instance sizing for Spanner to democratize access to it. With more granular instance sizing, you can start at 1/10 of the cost of a regular instance equating to approximately $65 per month. This means you can start small and easily scale your Spanner instance as your workload grows with no downtime. We recently also announced the launch of committed use discounts for Spanner to further reduce costs for customers committing to Spanner. You can get up to 40% discount on Spanner compute capacity by purchasing committed use discounts. Spanner committed use discounts are available now and are applicable for all Spanner instance configurations in all regions. For observability, last year we launched industry-leading observability with Cloud SQL Insights for Postgres. This has become one of the fastest adopted new capabilities for Cloud SQL. And you've asked us to deliver equivalent functionality for MySQL. Well, I'm thrilled to announce today the preview of Cloud SQL Insights for MySQL. Cloud SQL Insights empowers developers to address database performance issues themselves at no additional cost. Now let's take a look at a short demo of Cloud SQL Insights for MySQL.
Let's look at how I can use Query Insights to identify and diagnose a MySQL database performance problem in an application. Insights helps me investigate and detect problematic queries, find the root cause of the problem, and find the source in a single interface. Looking at the top-level Query Insights dashboard, let's start with the Database Load All Queries graph, which can help me visually identify performance problems or spikes in database load. The database load graph confirms there's a problem that started happening around 12 o'clock. The colors in the graph help me see that there's an increase in CPU weight and an even larger increase in lock weight. To try to identify which query is causing the problem, I'll start with the queries table, which contains normalized queries for the time frame selected. The first query in the table certainly stands out, as its total execution time is much larger than the rest of the entries. Now that I've identified that this is likely the slow query, I want to find out why. I'm going to click through to see more details for this query. Query plans can be complex and difficult to understand, but Insights provides visual query plans that can help me easily detect which part of the query is slow. Insights also provides in-context visualization of end-to-end tracing to help me find which application code caused the problem. Like many modern applications, this app consists of several microservices, and I want to know which one is causing the performance problem. Traditional monitoring tools only provide a query-centric view of performance. The tags table is especially helpful to me as a developer, since this application was built using an ORM rather than by writing the SQL queries directly. The first entry for the payment charge controller and the demo charge route looks like it's the problem. With this context, I can go look at the source code now to investigate further. Enabling Query Insights for Cloud SQL instances is quick and easy, and once enabled, it's always on, giving you access to a rolling 7 days of telemetry at no additional cost.
Wow, what an awesome demo. I'm really excited about Cloud SQL Insights for MySQL. For migrations, we've made migrations to Cloud SQL easy and fast with Database Migration Service. This offers a simple experience with minimal downtime for reliable and predictable migrations to Cloud SQL. It is serverless, secure, and offered at no additional charge. More than 85% of all migrations are underway in under an hour, and a majority of customers are migrating databases from other clouds. Database Migration Service supports MySQL and Postgres, with support for SQL Server migrations coming soon. Our customers want to modernize their Oracle databases to Cloud SQL for Postgres. And today, we are pleased to announce that Database Migration Service now supports Oracle to Postgres, schema, and data migration. This is available now in preview and offers a simple migration path from Oracle to Postgres. Database Migration Service integrates with the Ora2PG open source tool for schema conversion and provides serverless data movement and monitoring for your migrations. With this, you can reduce your costs and dependence on proprietary Oracle databases. Today, we're announcing that live migrations from Apache HBase to Cloud Bigtable is generally available. Bigtable is HBase API compatible and is a popular choice for customers to modernize their HBase clusters for better performance, scale, manageability, and cost savings. We have released features for live migrations, including a schema translation tool, replication library, and migration validation tool with the aim to make HBase to Bigtable migrations easier and faster for you. We know that migrations can be challenging. Therefore, we have invested in a comprehensive end-to-end program to help make your migrations experience fast, easy, and cost-effective. We do this by providing tooling and resources for assessments, project planning, and implementation. These efforts are further amplified with incentive funding designed to reduce the cost of your migration. Take advantage of this program and offer by getting in touch with your account team today. With that, I'd like to invite a customer who is driving data-powered innovation across their enterprise. We're fortunate to have Bala Natarajan from PayPal with us. Bala is the Senior Director for Data Infrastructure and Cloud Engineering at PayPal. Welcome, Bala.
Nice. Thank you. Thank you, Andy.
Bala, can you share PayPal's data journey with Google Cloud?
Sure, Andy. Thank you very much. PayPal, like many organizations, has become a data-driven organization. Many of our business users depend on data for their business-critical functions, including our CEO. When we looked at data lifecycle at PayPal a couple of years back, we observed that our business would benefit a lot by leveraging the cloud. Given the size of the ecosystem, we decided to slice and dice the approach to migrating to cloud. As a first step in the journey, we tried to take critical applications that were dependent on deep storage systems to GCP. This led us to adopt capabilities like BigQuery, cloud storage, PubSub, and Databricks. Our users got a full view of the capabilities of the cloud. They were clearly able to understand the interaction models, tools associated, how to debug their systems, and the cost associated with their actions. Teams who were managing on-prem systems educated themselves on their role in the new model. With this experiences behind us, we are now taking the next step in the journey to migrate our transactional processing system to the public cloud. This involves looking at all the applications that are receiving payments, onboarding users, settlement systems with our third-party vendors. All of them we plan to migrate to the cloud. We are excited about this journey. Our pre-work in evaluating some of the capabilities from GCP is very, very encouraging. We have narrowed down the offerings that we plan to use to migrate these systems over to the cloud, Andy.
So as a large and sophisticated enterprise like yours, you must have many different challenges with your existing transactional and OLTP systems, between custom solutions you've built on proprietary systems to various open source databases. Help us understand how you're thinking of leveraging our different managed services like Cloud SQL, Cloud Spanner, as you migrate and transform your workloads to the cloud.
Thank you very much, Andy. This is a great question. You're spot on that we have incredible diversity in our workloads that are sensitive. Some of them are sensitive to the site, and some of them are very mission critical that deals with money movement as well as settlement. We appreciate and love the ability and the flexibility to pick the right databases for each of these workloads that we have. The overarching theme here, Andy, is to leverage GCP's managed services as much as possible. Using managed DBs reduces our maintenance burden, reduces our toil on the teams to patch, to upgrade system, recycle hardware, or plan our data center. Based on our analysis, we have rationalized to 4 different swim lanes on how we are going to approach this problem. The first swim lane targets application that makes changes to use capabilities of GCP instead of using a traditional OLTP system. We have a bunch of examples where we landed up using OLTP infrastructure since we could not get access to anything different a few years back. GCP helps us with new capabilities where we can make a switch now and is also portable across our systems. Some of our batch processing and reporting workloads potentially fit under the swim lane. The second swim lane, Andy, consists of redoing applications or developing new products or applications that would benefit adopting open standards and tools. For example, GCP's commitment to Postgres is something we believe we can leverage heavily. This will help us and to build a set of application families to evolve on a robust foundation for a period of time. We are thinking about 4 to 5 years or the next 10 years as we migrate to GCP. The third swim lane, Andy, consists of applications that are critical for PayPal's payment processing and would benefit by usage of Spanner. The reliability and the cross-geo capabilities of Spanner is something we would like to leverage for a set of these critical applications, which require these capabilities so that they can scale across the ecosystem. The fourth swim lane, Andy, consists of applications that could be considered legacy and would need the same infrastructure to continue to run. For example, we have a lot of fleet in MySQL, and we plan to use Cloud SQL on top of MySQL to port these applications to the public cloud. And thanks, Andy, for asking these questions.
Lana, thanks so much for joining us today and sharing with us your story on how PayPal is transforming data in the cloud. Really looking forward to our continued partnership.
Thank you, Andy.
At the heart, Google is a data company. When it comes to managing data, we had to solve some of the most difficult problems. We reimagined databases and invented Spanner, a database that gives you the best of relational and non-relational databases. Our databases benefit from disaggregated compute and storage and our privately owned global network to improve performance, scalability, security, and availability. What all this means is that when you adopt our cloud databases, you immediately benefit from our long-standing culture of excellence and innovation. With that, I'd like to thank you for joining Google Data Cloud Summit. We hope to partner with you to accelerate your data-driven business transformation. Thank you.
Hello, everyone, and welcome to this session about artificial intelligence and machine learning on Google's Data Cloud. I'm Henry Tappan, Senior Product Manager for Vertex AI, here to talk to you about the latest advancements that can help you leverage your data through AI. You've probably seen through the summit how committed Google Cloud is to its mission of accelerating business transformations with data. We strongly believe that artificial intelligence and machine learning are critical to taking meaningful action from those data. Indeed, we're seeing customers from many industries and varying levels of ML expertise solve business-critical problems with AI-driven decision-making. Some use AI to improve customer service with more nuanced recommendations and smarter search. Others use AI to develop new products or improve their manufacturing processes. Chances are, like them, there's a transformational use case for AI waiting in your data. Unfortunately, though, despite many organizations devoting considerable effort to developing AI applications, most AI initiatives are still stuck on the tarmac. IDC found that only 36% of their surveyed enterprises had succeeded in putting completed models into production. Nearly half of the remainder hadn't even made it past the very beginning proof of concept stages. So, why would so many companies that have otherwise efficient software practices, plenty of data, and great data science teams still struggle to make AI work for them? For one, getting to AI deployment is a long, multidisciplinary process. Machine learning starts with data analysis, but quickly crosses over into statistics, computer science, and engineering, and then flows back again. Each switch along the way can stop development in its tracks. For another, AI comes with typically steep compute and data requirements. Inefficient usage and management of these raw infrastructure can make progress expensive, if not impossible. And lastly, AI development can have unpredictable results. After all, it's all about finding patterns in data that humans don't see. Traditional software engineering and analytics practices sometimes aren't ready to deal with this kind of uncertainty. We've learned from Google's years of experience in AI development just how large these challenges are and how to overcome them. Google Cloud's data and AI portfolio leverages these learnings to help you overcome them as well. The Data Cloud and Vertex AI are designed to get more AI models into production and help you realize real value from your AI programs. Specifically, it offers a unified notebook experience that gives you direct access to GCP's data and AI tools. This experience can ease completion of the many varied tasks in AI development. Secondly, it offers powerful services that solve specific AI tasks like training and serving ML models. These work efficiently with your data assets on GCP, giving you greater scale at lower cost. And thirdly, it offers an MLOps workflow and tooling that can guide you to successful AI deployments. Let's talk through each of these in more detail. First, let's see how Google Cloud's notebook interface makes data scientists more efficient. At this Data Cloud Summit, we announced the general availability of Vertex AI Workbench. Workbench is a single unified environment for data scientists and data analysts to complete all of their data and ML work, from data exploration and processing onto ML experimentation and development, all the way to deployment. Workbench builds new capabilities on top of the familiar Jupyter Lab editor. You can utilize all of GCP's data and AI tools through a code-first environment without having to jump through different applications. Within Vertex AI Workbench, you can apply whatever tool is best for the problem at hand, whether that's BigQuery through SQL, popular Python libraries like Pandas, or visualization tools like TensorBoard. And Workbench is just as good for administrators as it is for end users. It's serverless and integrated with GCP security tools like IAM, Org Policy, and VPC serving controls. So admins don't need to spend any time provisioning or babysitting instances. We've already seen Vertex AI Workbench save data analysts and data scientists tons of time, as well as surface new insights for them. One exciting integration we'd like to show off is Vertex AI Workbench's connection to BigQuery. You can immediately compose and issue queries inside of a notebook without adding any boilerplate code. Your BigQuery information is brought into the notebook so you can browse and inspect tables as you compose queries, giving you that critical information that's necessary to get the right query in place. And best of all, you can pipe BigQuery results into Python data science libraries like Pandas and scikit-learn. Mixing and matching SQL and Python code can help you better understand your data and uncover new insights. Vertex AI Workbench comes with similar integrations to other GCP tools in the Data Cloud. For one, you can connect the Workbench front end to Dataproc clusters, letting you run Spark code interactively or kick off serverless Spark jobs. And when your data crosses BigQuery, Spark, and other tools, you can jump between each backend in the same notebook without having to leave the editor or spinning up new instances. Now, these features are just the beginning of what will be possible with Workbench. Over the next year, expect to see deeper integrations into BigQuery, as well as new collaboration features that help your data scientists work together as they complete end-to-end data and ML journeys. And when the time comes to train and deploy a model, GCP also has you covered. We offer highly scalable, serverless infrastructure to tackle even the most complex AI problems. We've especially optimized for simplicity and scalability when it comes to using AI with data in BigQuery. BigQuery ML allows you to train and deploy models using simple SQL commands. Like any other query, BigQuery ML totally manages the infrastructure behind your ML jobs, dynamically spinning up and scaling as necessary. It gives you a wide array of algorithms to solve various problems, from basic linear regression and classification all the way up to matrix factorization and other advanced techniques. Plus, BigQuery ML fits into BigQuery's usual billing, quota, and capacity configuration, making administration a piece of cake. Over the last year, we've introduced tons of new capabilities to BigQML, including time series forecasting, integrations with AutoML, and support for unsupervised models, plus explanations for the model's behavior. In the next few months, expect to see BigQML get even smarter when working with unstructured data like text, and easier to fold into an MLOps program. More on that later. You have the same degree of flexibility and power when it comes to workloads using frameworks like TensorFlow and PyTorch. Within Vertex AI, you can run any Python script or Docker image on virtually any hardware configuration, including instances with GPUs and TPUs. You can then deploy models generated behind dynamic online endpoints that automatically scale up with your traffic. Now, all of this comes with no hardware management. It comes with comprehensive monitoring and total flexibility in your software. These services work in concert with the Vertex AI feature store, which ensures that you have consistent model inputs during training, batch, and online inference. We've been especially invested in the speed and scale of this service over the last year. On top of numerous performance improvements across the board, we've launched new specialized capabilities like Matching Engine, which greatly accelerates the training and serving of nearest neighbor lookups for tasks like product and media recommendations. In 2022, we'll continue to make training and serving faster, launching new tools that automatically optimize models and infrastructure for even greater efficiency. Now that we've seen how Google Cloud can help you develop and scale up a model, let's talk about how we can help you maintain it. Getting the first version of a model into production is a great success, but you should always expect that week over week, you're going to need to update it. After all, most AI systems operate in dynamic environments where things like customer behavior or available content changes quickly. Plus, data scientists will often find ways to improve their models. Updating a model means much more than pushing out new code, though. You need to rerun all of the data engineering and model training steps as before. After repeating those tasks, you still need to ensure that this new version is an actual improvement over the older one. The magnitude and variety of tasks involved in these active ML workflows can stretch typical software automation, let alone manual processes. Instead, we need new processes and tools that are special for AI. We call this ML Ops. Now, this is where Google Cloud Vertex AI really shines. Vertex AI gives you a workflow that helps you put together complete AI training and deployment journeys that can repeatedly update your models as new data comes in. In particular, Vertex AI Pipelines lets you orchestrate all of the data and ML tasks that produce a model. This workflow gives you total flexibility in the tool that you use to complete each particular step, whether that's specialized services like Dataflow and Dataproc for data generation and engineering, or generic Python code for all the other tasks. You can easily mix and match different tools inside the same pipeline. In fact, we've just rolled out new pipeline components for BigQML that allow you to easily put together journeys stuck entirely inside of BigQML or interacting with other components like Dataflow. In addition to this overall workflow, Vertex AI also helps you maintain high-quality models before and after you deploy a new version. Vertex AI's model monitoring suite tracks and warns you when the data flowing into or out of a model changes, signaling the need for an update. Now in 2022, we've got a lot of exciting things coming. We're going to make the pipeline system much more reactive and easier to set up these kinds of ongoing workflows, as well as introducing tons of new bespoke tools for essential ML tasks. Now, once you get to regularly updating models, managing the sheer number of artifacts can quickly get out of hand. And that's why we're launching Vertex AI Model Registry at the Data Cloud Summit. The model registry organizes your model artifacts by version, making it easy for data scientists to share models and application developers to consume them. Model registry is designed to work with any type of model and deployment target, whether that's through BigQuery, Vertex AI, custom deployments on GCP, or even out of the cloud. It features especially smooth integrations with BQML. From the same SQL commands to generate a model, you can immediately export to a model registry with no extra code. Model registry also links the critical metadata and lineage that can help you understand when and how to apply a model. Over time, we're going to expand model registry's capabilities to cover critical model approval and governance workloads. So let's wrap this up. While AI can benefit many companies, it comes with unique challenges around the variety and number of ML tasks, the management of compute and data, and the maintenance of models over time. Google Cloud solves these challenges with a unified notebook interface, simple but powerful compute options, and a complete MLOps toolkit. This is just the beginning of what GCP has to offer. If you want to learn more, we'd love to see you at the Applied AI Summit later this year. Now I'll pass it to Olivia, Dale, and Travis to tell you more about how this tech works in practice.
Thanks, Henry. Hi, everyone. I'm Olivia Burgess, Product Marketing Manager for Vertex AI here at Google Cloud. We're going to dive in and explore a real-world example of how machine learning with Vertex AI is transforming Mayo Clinic, the data science teams within it, and ultimately the patients it serves. It's my pleasure to welcome Travis Drucker and Dale Magnuson from Mayo Clinic. Dale and Travis, could you please introduce yourselves and share more about Mayo Clinic's AI strategy?
Certainly. Thank you for having us today. My name is Dale Magnuson, and I am an IT section head at Mayo Clinic, leading a team that is implementing AI Factory on the Google Cloud platform. AI Factory enables GCP capabilities in a HIPAA and high-trust secure environment for Mayo Clinic data scientists, AI, and ML users.
Hi, I'm Travis Drucker, Senior Service Owner for AI and Data Services and Products within Mayo Clinic Cloud. Mayo Clinic Cloud is the program within Mayo Clinic where we are building out our next generation enterprise data, artificial intelligence, and software development platforms on the Google Cloud platform, leveraging our strategic 10-year partnership with Google. As Dale mentioned, AI Factory is the name of our next generation enterprise AI platform. AI Factory includes two key services, discovery and model hosting. Discovery is a data science environment where users can analyze, visualize, process data sets and utilize them to build, train, evaluate, optimize, and validate statistical and machine learning models. Model hosting is a set of development, testing, validation, and hosting environments where statistical and machine learning models and their associated data processing pipelines and microservices can be productionized, validated, and deployed for clinical, business, and research use.
And what kind of business problems were you looking to solve when you started working with Google Cloud and ultimately adopting Vertex AI?
Initially, our goal was to be able to provide on-demand compute and storage on GCP for Mayo Clinic data scientists, AI, and ML users. In healthcare, this has traditionally required procuring physical hardware and placing it in a data center, which takes time. By offering a HIPAA and high-trust secure environment, our users can get access to compute and storage much faster. Vertex AI allows our users to be more efficient in their usage of Google capabilities.
Over time, we wanted to build out our platform, adding services and capabilities like AI building blocks, AutoML, and BigQuery ML. This would allow users with little to no machine learning experience, but deep medical and science knowledge to utilize existing models or generate custom models to better diagnose disease, optimize treatment plans, predict patient outcomes, determine causes and mechanisms of disease, and discover new drugs and treatment regimens. As an academic medical center, we need to ensure our platform and the services we utilize meet the strict regulatory, security, and privacy requirements for storing and processing research participant data and utilizing statistical and machine learning models for clinical decision support.
And why did Mayo Clinic choose Vertex AI? Was it easy to get started?
As I mentioned earlier, Google and Mayo established a strategic 10-year partnership back in 2019 to combine the technical and data expertise of Google with the clinical knowledge and expertise of Mayo Clinic. As an academic medical center, Mayo has unique security, privacy, legal, and operational and regulatory requirements that other GCP customers often do not have to contend with. Our core value at Mayo Clinic is that the needs of the patient come first, meaning that everything we build and do has to have the patient in mind. Our patients have entrusted us with their medical care and everything that entails. So the path we need to navigate is naturally more complex than most GCP customers. Thankfully, we have Google as a partner helping us forge that path.
And you've been working with our notebook service through Vertex AI Workbench for some time now. What has your experience been with this, and how do you find yourself benefiting from the new features?
The new features in the managed notebooks are something that our users will be able to take advantage of quickly. Many of our users are new to GCP capabilities, especially BigQuery. By being able to leverage some BigQuery capabilities integrated in a Jupyter Notebook, end users will have greater abilities than they've ever had before.
Allowing our users to natively access other GCP services directly within the Vertex AI Workbench has streamlined our users' workflow, minimizing the context switching between browser windows, and bringing the tools they need into a single, simplified, easy-to-navigate user interface. We currently leverage the user-managed version of the Vertex AI Workbench to persist the innumerable tools, complex dependency chains, and custom configuration required to process the myriad of healthcare and life science data sets we utilize. We are interested to see how the managed version of the Notebook Workbench will meet a subset of our users' needs. We are also looking forward to the integration of additional GCP and Vertex AI services directly into the Workbench, further simplifying our users' workflow.
And how do these tools help you to empower your data science talent to do their best work?
Many of our data scientists and AI/ML users have been accustomed to writing their own code. The power of GCP allows them to take advantage of Google APIs such as AutoML and Document AI and many others, which may help them gain insights about their data cohort much faster. These capabilities are newly available to users at Mayo, so we are still learning the value they can provide.
We have many different types of talent, from machine learning experts who write their own tools, frameworks, and model architectures in Python and R, to novices with little to no data science or artificial intelligence knowledge or skills, but have deep understanding of medical conditions and their biological mechanisms. We need to support all types of talent by providing a wide variety of tools, services, and capabilities. For the experts, we need to provide them access to scalable, cost-effective, and secure infrastructure and APIs for developing, validating, and running custom data processing pipelines and statistical and machine learning models. For the novices, we need to provide access to easy-to-use data analysis and visualization tools, pre-trained models, or model generation services via intuitive, well-designed graphical user interfaces. In both cases, we need to provide clear, concise documentation, examples, and tutorials that work in our secure, HIPAA, and high-trust tested environments.
We're thrilled to contribute to the transformational AI journey of Mayo Clinic. Thank you so much, Dale and Travis, for your time today and for sharing your insights. And to everyone tuning in, remember that you can invite your data scientists and machine learning engineers to the Applied ML Summit on the 9th of June to get hands-on with Vertex AI and explore how you can bring this level of transformation to your own organizations. Thanks so much for joining and have a great day.
There is a fundamental truth in our nature. Humans are curious. It's wired into our DNA to wonder about the world, the universe, and our place in it. So we ask questions, observe the answers, and gather information. Volumes and libraries and oceans of it. And now we finally have the tools powerful enough to help make sense of it all. To ask bigger, more meaningful questions. How can we use AI to identify the resources we'll need to live on the moon? So we can build an outpost there and use it to get to Mars. Questions that help us look at problems in entirely new ways. How can we optimize millions of images to predict when the next great solar flare will occur? Will that give us enough time to protect the satellites that connect us all and avoid a power grid shutdown? Questions that are becoming increasingly more urgent. Can we generate hyper-accurate maps to identify a flood zone? that will help people evacuate before the rains even start? As the climate changes, what can we do to better protect our planet and everyone on it? Scientists from all over the world have come together to find answers to these questions, and others like them. Digging into their data, breaking it apart, prying insight and inspiration and progress from it, hoping to solve some of humanity's biggest problems.
Hi, everyone. My name is Brendan Foley, a customer engineer here at Google. I'm joined today by James Spiteri, a product marketing director at Elastic. We're both very happy to be here today and to talk to you about how teams and organizations can utilize the Elasticsearch platform on Google Cloud to investigate and prevent application exploits. We'll also talk about the advantages of combining application observability and security events into the same platform, and we'll see this live in a demo. We all know that data is at the heart of the modern enterprise, and needless to say, at the heart of modern security analytics. Unfortunately, security teams have long relied on what we consider traditional security events. Think endpoint logs, firewall logs, etc. While these are, of course, important, the events which occurred in December showed how those are simply not enough. Following the events which occurred in December, it became even more evident why these different solutions shouldn't be siloed. James, why don't you go ahead and explain what you'll be seeing as part of the demo?
Yeah, awesome. Thanks, Brandon. Before we shift into the demo, I'll just quickly talk through the slide that I have here to show the setup we'll be using for this particular use case, which was the log4shell exploit, which are the events Brandon was referring to in December. So we've got a vulnerable Java application running here on our hosts, and we've just exploited it with log4shell. This application is instrumented using our Java APM agent, so application performance monitoring, which is going to give us really deep insight into exactly what the application is doing. That data is being streamed into an Elastic Stack hosted on Google Cloud. Here's a demo now to talk about the other infrastructure elements and everything else we have running on our machines and how we can use the different solutions within Kibana to investigate this exploit. Okay, so let's dive right into the demo. So first things first, I just wanted to show you all the components that I've set up for the purpose of today. So we've got an Elastic cluster running out of Google Cloud, specifically the Belgium region. This is the Elastic Cloud Console, but you can also invoke the creation of these clusters through Google Cloud Platform itself. And we have various different regions that you can use. From the Google side, we've got a couple of compute instances that we'll be monitoring. We have Google Cloud Bucket, which is going to be used for an Elastic feature called searchable snapshots. It is just an ordinary Google Cloud Bucket, but it's going to be used for a very powerful purpose. We've got pub subtopic, primarily collecting our Google Cloud firewall logs, and of course the Google Cloud firewall rules themselves. This one specifically is going to be doing the bulk of the work for us. Now that we have everything set up, let's see what it looks like on the Elastic side. So we've got our Elastic Agent Google Cloud Platform integration, which is collecting primarily the PubSub events. We've got our Elastic Agent also running our endpoint security integration on those compute instances. Now, I've said that we've exploited a vulnerable vulnerable application with the log4shell exploit. Let's see what we're able to find now within Elastic with all these Google datasets. So, looking at our alerts view inside of Elastic Security, we had a couple of different things that we can see. Primarily, we saw an alert for suspicious Java chat process, followed by a couple of malware prevention alerts. The exploit I invoked from log4shell does just that. It does try to download malicious files and run them. This is exploits I've seen from honeypot data, so this is what people have been trying to exploit in the wild. We can see here, thanks to the Elastic endpoint and the security views, we get a very nice process tree view of what happened. And again, the malware prevention alert, as well as some threat intel indicator matches. These are all standard out-of-the-box rules, by the way, so it's not like I created anything custom for the specific exploit. We do have some threat intelligence enrichments here, and we can see that this is now given a high-risk profile as well. But from a security analyst perspective, I don't know that this is log4shell, right? I have no idea that it was exploited. But thankfully, I have all the applications on this host using our application performance monitoring, APM. Since they're Java applications, it's very easy for us to instrument. So I'm going to pivot to that view. It's within the exact same console. We're going from security to observability instead. And I've got my application running in Google Cloud. You can see it's very clearly indicated over there. And I can see a couple of transactions which happened. If we click on the transaction, we'll be able to get pretty much everything that the application did at that point in time. I'm just going to go to the first sample here, and we can see that it was invoked via curl because I ran this manually. But first thing we see is the main instance of the transaction being invoked. It was a Java application, yes, we know that. But we can see in the request header, this is what that exploit looked like, right? To the eyes of the analyst, it ended up being the coded base 64 command, but they hadn't seen this yet. There weren't any logs or alerts stating that, or I should say with this content. We got this from the application view, which is great to see. But what is even more interesting is what happened right after. So thanks to this application view, we can see that right after the main transaction was invoked, a GET request to this random IP on this random port was made. And it was actually invoked via the JNDI manager from Log4j, which is exactly what Log4shell does. And you can see it tried to download this class, which is, again, very indicative of Log4shell. So if I'm a security analyst, I had my security alerts trigger, pivoted to this application view, and then I have pretty much all the information I need to put two and two together based on what, even if I just did one second of research online about JNDI manager, I can probably going to tell that it's Log4shell. Now, we've basically seen what happened today, right? But what I want to do is use that searchable snapshot feature I was talking about to dive a bit deeper. So what searchable snapshots allows you to do is store data on very cheap storage, like archive storage, like a Google Cloud bucket, but still be able to search it as if it was data from today. So I have a timeline here where I'm going to do just that. Here's a correlation from today, which I ran, which essentially I'm looking for processes like curl and wget. And within a 2-minute time period, we want to see if those processes made any network connections on our Google Cloud firewall data. And we can see that happening right here. We've correlated based off of the destination IP. And thanks to the rich information I get out of my logs coming from PubSub, this is really easy for me to understand what happened because all the detail is provided in there. But if I wanted to go back and say, let's now search instead of today, let's go over the last 1 year. Elasticsearch in the background knows that it should use the searchable snapshots. So we do that automatically. As an analyst, you don't have to decide where to look from. So my data from July 22nd, 2021 is telling me, listen, you've had requests to that IP address that was hosting the malware. And we've gone and looked on that archive. This is set up in our index lifecycle management policy. So you can see here, I have a frozen phase, which goes into that searchable snapshot repository. And just to show you as well, if you look at the data storage size for those logs stored in the snapshot, on the physical storage of my cluster, it's saying 0 bytes, which means it's all in the archive. So there's nothing, I'm not using expensive storage from my compute instances. And that's pretty much it from a demo perspective. We'll wrap up with a couple of more slides.
Thanks for that, James. Hopefully you all saw how powerful it can be to combine application data with security data into a single platform such as the Elastic Stack. Thank you all for joining and enjoy the rest of the conference.
Hello, everyone. Welcome to our Spotlight session, Cloud BI Product Roadmap. My name is Pedro Arellano. I'm part of the product management organization for the Looker team at Google Cloud. And it is my great pleasure to give you an overview over the next 20 minutes or so of the very exciting projects that the team is working on for 2022. I'm going to start with a brief explanation of our product strategy and vision. This is so that I can give you some context, which is going to help you understand how we think about business intelligence and how that guides the investment decisions that we're making when we think of our roadmap. Then I'm going to dive into the roadmap in detail and get into all the specific features that the team is working on. Rethink BI. This is a core idea that guides the Looker team when we're thinking about what we're going to be working on in terms of the product roadmap. And what does it mean? It means that when we think about business intelligence and data and analytics in general, we see a bigger opportunity. When we think of BI, we see problems that haven't been solved yet, and we see people that haven't been helped yet. And the work that we're doing every day is to build technology aimed at helping those people and also aimed at helping your organization help those people in new ways by breaking the conventional paradigm of BI. And what do we mean by that? The conventional paradigm of BI is the use case that those of us who have been in the BI space any extent of time are very familiar with. And it's the one that we all think of when we think of BI. You have a data analyst that is sitting in front of their computer screen and they're looking at data visualizations. It's a use case that our industry has been laser focused on since its inception for the past 30 years or so, depending on when you start counting. And don't get me wrong, it's a very important use case. Even though it is conventional, it matters a lot. In fact, many of Looker customers use our BI capabilities to understand their businesses, to run their businesses, and make smarter, better decisions. It's a massively important use case to a lot of organizations and it's not going away. I want to be very, very clear. In fact, as I'll show you in the section of our roadmap when we go over the individual features, you're going to be able to see that we're making some pretty big investments in releasing new capabilities that are going to make the experience of working with our BI tool even easier, faster, and more intuitive. So the point is that we care about that paradigm a lot. But, there is a but, we also recognize that not everybody wants to work with something that feels like a BI tool. There are many different people in an organization in many different roles that have different needs. There are some people, like data analysts, that are looking for something that feels like that conventional BI experience. But there are a lot of people who are not looking for that type of experience. They're looking for something different. I like to share this anecdote of a former colleague of mine who articulated this idea in the most eloquent way I've ever heard. He said, there are many people who need data to do their jobs, but their job isn't data, right? You have data analysts and data engineers and data architects and data scientists. The word data is in their job title. But then there are a lot of other people who don't fall into that category, but they still need data to make decisions. And that group of people has historically not really been served very well by this industry. Our industry for decades has tried to pull all these people into a BI tool. And you'll hear marketing messages about, let's turn everybody into a data analyst. And at Looker, we strongly disagree with that idea. We strongly disagree with the idea that you should force people into a role that's not natural to them. Instead, what we want to do is we want to reach people in the tools and the systems and the applications and the experiences that they already use today, that they're already familiar with today. We believe that our platform should deliver insights to people in a way that makes most sense to them, to the work that they do, to the systems and the applications that they already use, to the way that they naturally work and think. And for some people, that's going to be something that feels like a BI tool, but for others, it'll be something that feels completely different. And that is what we're building here at the Looker team, what we call a complete, open, and integrated platform that can deliver any kind of data-driven experience that is tailored to the way that everybody in your organization works. We want it to be a very inclusive platform that can help people who are very familiar with working with data, but also those who are not. And our roadmap is categorized by 3 specific areas that are represented by the colored rectangles that you see on the screen. Starting with that blue box on the left, that represents our platform's end-to-end capabilities for modern BI and analytics that are delivered out of the box, so that you can do anything that you want or that you would expect from a BI tool, from data modeling all the way to data visualization, all with the Looker platform. On the right-hand side, that red box, those are our application development tools for anybody that wants to deliver an experience that maybe is not available out of the box, but you want to build something that is very tailored to a set of users or a department in your organization or a business process in your company. You can do that. You have a rich development framework available to you that allows you to build any kind of data application for your internal users, or even build a data product that you want to build to market and maybe even commercialize for your external customers. And now that yellow box in the middle, it's about us wanting to be an open and integrated platform that can work with any tool that your users already use today, whether that is something like Google Data Studio or Google Sheets and Google Slides, or even third-party BI tools. It doesn't matter if Looker built it or you built it using Looker's development platform or another vendor built it. We want Looker to be able to enhance your experience of working with data and insights. And of course, because this is Looker, all of this works on top of this modern semantic layer, that long horizontal section you see in the middle. That modern semantic layer, that what it does is deliver a curated set of trusted business definitions that is available to everybody. Everybody can use, regardless of their skill level. And that is how we are rethinking BI. Now, I want to drill down on one particular item from the previous slide, which is our open and integrated connectivity. Specifically with Data Studio, because this is going to be a deeper integration than some of the other ones, because Data Studio is now part of the Looker team. And together, Looker and Data Studio represent Google Cloud's BI portfolio. Now, the integration between Data Studio and Looker is something that we're very excited about. It's going to be a long integration journey, as you can imagine, but it opens up so many exciting opportunities to support new use cases that maybe we haven't been so good at supporting in the past, and also deliver new capabilities by combining the strengths of both products together. As I said, there's a lot of work that we're going to be doing, and it's an integration journey that is just starting with many possible future destinations. However, we already know that we're going to be working very hard on two specific initiatives this year to begin unifying the products. The first one is that we're going to enable Data Studio users to query Looker semantic layer. This is going to bring curated, governed data to Data Studio queries, and it's going to enhance the Data Studio self-service model with well-governed, trusted data from Looker. What it also means is that you're going to be able to do things that combine the strengths of both products. For example, end-user data blending. I'll give you an example. Today, if you wanted to analyze your sales actuals and compare them against your forecast, maybe your actuals are coming from Looker. Maybe you have them in BigQuery and there's a Looker model sitting on top of it. But your sales forecast is lying in a spreadsheet somewhere, which is something very common. In the old world, you'd have to find a way to bring that forecast into the Looker model. With Data Studio and Looker together, you no longer have to do that. Your actuals come from the Looker model, but your sales forecast can be ingested right in that spreadsheet through Data Studio. And using Data Studio's end-user data blending capabilities, you can bring those two data sets together and actually compare your sales forecast against your actuals side by side. So those are some of the new use cases that we'll be able to support that we're very excited about. Second is that we're going to be able to include Data Studio usage activity as part of Looker's administrative capabilities. As an administrator, it's very important for you that you maintain a great level of visibility and a measure of control over the usage of Data Studio across your organization. This is going to help administrators have that unified view of everything that's happening with Data Studio, so you'll understand things like data lineage and protect against issues like data exfiltration. So with that background, let me dive into our 2022 roadmap. First, we're very excited to announce that Data Studio customers will be able to access the Looker governed semantic model. So this brings that combination of governed data with agile self-service together as part of Google's Cloud BI portfolio. Through this integration, a Data Studio user is going to be able to access all those centrally defined metrics that you can use broadly across the organization, and everybody that's using Data Studio will have that same interpretation of the data. So with the integration between Data Studio and Looker, users can bring that centrally defined data that they wish to analyze and blend it with other available data sources that they want to ingest with Data Studio. We're also very excited to announce that starting now, any Looker customer with a Workspace Enterprise license can start using Connected Sheets for Looker on an opt-in basis. So with Connected Sheets for Looker, users can use that familiar spreadsheet experience and use it to analyze data that is coming from the governed Looker semantic model with all the capabilities that they're already used to, like formulas and pivot tables and charts. It's a feature that we're very excited about. We're already getting just some excellent feedback from customers For example, Mercado Libre in Argentina, they are one of the largest e-commerce organizations in South America. And they've been one of the first companies that's been using connected sheets for Looker. And you can see there how they say that it blows their mind. And they can offer this to somebody who doesn't know anything about data, but they'll have the same power as analysts, and they think it's awesome. So that's exactly what we're looking for here. Again, just providing that valuable experience of working with insights in a way that's very natural to the way that people work today. In Data Studio, we're also coming up with better data blending. So we have improved blending support for more types of joins, right join, inner, outer, cross joins, in addition to the joins that we support today, which is left joins. We're also rolling out the ability to support joins for data sources that don't have a common join key. Also, in the first half of this year, we're going to be rolling out a new filter shelf for Data Studio. It's going to enable Data Studio users to slice and dice your data without having to add a filter control to the report canvas. Looker for Google Slides is a feature that we're also very excited about, continuing with that integration with other tools and other experiences, giving Slides users the ability to bring in or embed analytics or insights from Looker, the visualization from Looker, into a presentation they're creating. You can add that visualization as many as you want, and then any time that you have to give that presentation, you can just refresh the data that's coming from Looker, giving you a really great way to communicate data using Google Slides. We're integrating with Google Maps. One of the great things about being part of Google is that we can take advantage of features like Google Maps. So all of your geospatial analysis, you'll be able to do that with Google Maps as the geo engine underneath. Ask Looker is another feature that we're very excited about, and this brings the power of artificial intelligence, specifically natural language, into Looker. So your users, instead of having to assemble an analysis in the traditional way, they'll simply be able to type in a question and Looker will answer with the corresponding insight. So imagine how much that brings that barrier to entry, if you will, of working with BI, of working with insights for people who are not necessarily very data savvy or are experienced working with a BI tool. Again, just that experience of giving them something that doesn't necessarily feel like a BI experience, but allowing them to work with insights in a way that's very natural to them. This is going to be available in preview in Q2 of this year. Anomaly and insight detection. This is another area where we're taking advantage of all the surrounding research that's happening around us at Google. Things like signal detection technology and multivariate analysis, being able to bring that into Looker and giving the product intelligence to monitor how many metrics are behaving in a way that would be very hard for a human to do. The product now has intelligence built in, and it can see how all these different measures are moving up and down within a band of what we would consider normal. And any time the measure goes above or below that band, it will trigger an alert. And because this is Looker, the feature leverages that semantic model, that semantic layer, and can identify the drivers of those anomalies and all the correlated metrics. We're improving the Looker mobile experience. We know that it's very important for people to be on the go. We're all carrying our mobile devices now. So instead of having to pull you into the BI tool, we're giving you all those insights on the phone, on your device, on the go. And we want to make that experience as natural as possible. So we are leveraging natural capabilities of the device, like push notifications, that will take you directly into the analysis when you tap it. We're also closing the gap between the experience of using Looker on your computer and using Looker on your phone with things like cross-filtering and drilling. Coming in the second half of the year in preview mode, something that is very interesting is the ability for third-party BI tools like Tableau and Power BI to query the Looker semantic model. So similar to how we would have users of Sheets or Slides or Data Studio use those tools as their front end, but Looker in the back end, same thing here. If you're a user that is familiar with Tableau or you really like Power BI, we want to enhance your experience by putting that layer of governance and trust underneath all the queries that you run. So as a customer, you'll have the option now of using the visualizations that come out of the box with Looker. And many of our customers prefer that because they want the sort of that single solution for all their needs. Or maybe you're an organization that's already invested in one of these tools and your users want to keep using them. Instead of forcing people away from those tools, why not make their experience even better with the Looker semantic model? So that's also something we're excited about. We're integrating with data workflow orchestration tools. Looker customers leverage PDTs, persistent derived tables, to make their experience a lot better, reduce the database load, increase query performance. Now you're going to be able to use tools like Google Cloud Composer, Apache Airflow to manage the running and upkeep of these PDTs, along with any data pipelines that you might have, even if they're not related to Looker. The Looker Marketplace Developer Program is something that we're also excited about. So this is going to help the Looker developer community. It's going to give them a great way of creating content, but also submitting that content and sharing it, contributing it to the rest of the Looker developer community through the marketplace. And in the marketplace, people will be able to see all the content that other people are developing and then immediately instantiate it into their own Looker environment. The marketplace exists today, but right now it's very Looker-centric. It has to go through the Looker team in order for content to be published on the marketplace. Through this developer program, we're going to let you be able to do that. And then finally, VPC security controls. So we know that security and privacy is something very important to all of you, and it's something very important to everybody at Google. So VPCSC enables customers to connect to API-based databases like Spanner, like BigQuery, using a secure, private network connection. And this is going to become available and generally available this quarter. So we're very excited about that. As you can see, the Looker team is very busy and we are working on a lot of exciting projects for all of 2022. All of these projects are heavily influenced by your feedback. So we welcome and we encourage all the input that you have about your experience using the Looker platform and the Data Studio platform as well. We greatly appreciate your support. We greatly appreciate your feedback. And on behalf of the Looker team, we want to thank you for your time today, and we hope you enjoy the rest of the Data Cloud Summit. Thank you.
Hello, everyone. Welcome to Data Cloud Summit. Welcome to the session on solving for the future with Cloud Spanner. In today's session, we're going to focus on how Walmart goes about building its next generation data platform using Cloud Spanner. My name is Pranav Nambiar. I'm a Director of Product Management on Google Cloud. I also have with me Bob Lowell, who's a Senior Director of Engineering at Walmart. Together, we are today going to talk more about Cloud Spanner and how you can go about your digital transformation journey with using this service. In today's world, we put a very high bar on customer experience. And what we're seeing is that digital innovators are disrupting traditional industries by finding unique ways to manage their data to deliver highly personalized and enriching digital experiences. Whether it's a ride-sharing application or a gaming experience or a retail experience or a payments platform, across the board, there's a very high bar on delivering differentiated customer experience. But to deliver a differentiated experience, you need sophisticated applications. You need applications that can scale to millions of users. That way, you don't end up with a crashed application when you have a lot of customers. You need applications that don't go down. You need applications that are very flexible, that are very performant and secure. You need to be able to leverage your application to deliver an enriching digital experience. When you look at all this from a high level, you will see that the most controlling factor here is your data management layer, where you have your business critical data. This is the data that is critical to innovating on your customer experience. To put another way, to build innovative customer experiences, you need transformative databases to hold your operational data. You need a database that delivers you industry-leading availability without any concept of a maintenance downtime. You need a database that can scale to whatever needs you want without you having to manually shard your data and manage your database. You need a database that can manage faults automatically, that can be price performant and secure. All in all, I'm sure you would have faced similar problems with your databases. Google too went through the same problems with its applications. And after a lot of research and effort, the end result was Cloud Spanner. Cloud Spanner is our horizontally scalable relational database that provides you ACID transactions and SQL capabilities at pretty much any scale with 5 nines of availability SLA. Today, Spanner is used by a number of large customers. Spanner also powers most of Google's large applications. In fact, Spanner today powers more than 2 billion requests per second at peak. If you think about it, to operate at this level of scale, you need a system that is really pressure tested in a very intense and highly demanding environment. And it's very difficult to find similar systems out there. On that note, let me invite Bob, who's going to share with you Walmart's perspective on Cloud Spanner and provide you more details into how they went about their digital transformation journey. Over to you, Bob.
Hey, thanks, Pranav. Appreciate it. Appreciate the opportunity to share our journey. I've been doing database administration and engineering for a long time, as you can see on this slide. I've been lucky enough to spend a good chunk of my career at Walmart, where the scale and complexity of the problem statement is fairly unrivaled. I came to Walmart to really help them with their journey to cloud, specifically around data. And the problem statement is basically, how can we build a platform that enables our application developers to focus on the business problems and deliver them a platform where they can access, store, secure, and enter their data into a complete data ecosystem without having to architect that all themselves. So Walmart is obviously a big operation. It's also a global operation. We've got 11,000 stores across the world in 20 different countries. Some more interesting facts about Walmart's scale and the impact that Walmart can have. That's one of the most exciting things to me about working at Walmart is the impact that we can have. Suresh Kumar, our CTO, said the other day, at Walmart, you can write a single line of code that can improve the lives of millions of people. It's true, and it's very powerful. The ability for us to help deliver these experiences is it's very motivating. The other thing that stands out to me on this slide is 2.2 million employees worldwide. You think about that, and even the HR systems at Walmart scale well beyond what most companies have to deal with. So digital transformation at the scale of Walmart
is a pretty consistent thing, right? We can't take 40,000 or so different database systems and just upgrade them or change them overnight, right? You have to attach to building great customer experiences. You have to attach to what the company is trying to do to find the right opportunities. We spend a lot of time working on omni-channel experiences, the merging of online and in-store experiences. So the line is blurred between the two. We modernize the platform by aligning with those experiences that Walmart wants to create in order to transform the business. And that's how we get we call them locomotives to pull our technologies forward with the locomotives of transformative experiences. So this is just a quick picture of kind of how we have our system of record data. We basically have, you can see a good chunk of relational databases. Relational databases have been the powerhouse for many, many years. Mainframe databases, as well as some NoSQL databases. So what's the problem with that? Walmart has to have elastic scale. As you could probably guess, Black Friday, Cyber Monday, we scale sometimes 10 to 100x what we'd be doing in a normal day. We have to have great HADR, BC, because 1 minute of downtime is huge revenue loss for Walmart, and we really can't afford it. We can't afford an active passive system that's going to take me 3-4 minutes to fail over. Sharding is something we've done in the past. We have a lot of sharded systems, but it adds a lot of complexity, right? There's a limit to the vertical scaling that you can do with a relational database, and it forces you into partitioning in ways that might not be natural for the application. We need to be able to get data downstream to all of our customers. Relational databases have some decent tools for that, but not everything does. We need to be able to capture metadata and push that downstream as well. Jumping to the bottom one there, NoSQL solves a lot of these problems, but the lack of transactionality is really difficult when you're talking about payment systems or capturing transactions that really need to be captured in an ACID compliant way. So as we're looking at our transformation, we have a set of principles that we look at in order to guide us on that journey of taking a technology and transforming, or taking an application really and transforming the way that we're going to build a platform for it. First of all, we want to be cloud native. We need to take advantage of all the availability and the geo-distribution that cloud native can offer, the elasticity that cloud native can offer. And the first thing you really need to do is understand your access patterns for different applications. Understand what the business is trying to accomplish. Those things go hand in hand. You need to really deeply understand what the business is trying to do in order to apply the right technology to it. So you need to look at representative workloads. You need to benchmark. We need to figure out the best way to standardize data access. Without a standardization, you get a lot of snowflakes, and it becomes very hard to maintain in an enterprise environment. We always, like I mentioned before, want to have change data capture, and of course, time to market is always a pressure, right? Walmart is moving very quickly to transform the way people shop, and they need a platform to do that on. So we need to move quickly to make that happen. We use what we call best of breed to define products that fit our needs. And a big part of that is what we call the ilities, whether it's observability, availability, scalability, operability, security. All of these things need to be addressed in order for us to be successful, to successfully offer a platform, and have to be baked into any product that's going to end up on our best of breed list. So the good news is Spanner, obviously why I'm here, Spanner fit into that best of breed category. Looking at the cloud native capabilities, the multi-region capabilities were very important to us. The uptime, of course, all of the factors were things that we deeply evaluated, partnered with Google on to make sure that they met the ilities part of the requirement. as well as the capabilities part of the requirement, the features that our customers needed in order for us to transform the way that they're operating their portion of the business. So my key insights on transformative digital transformations or digital transformations is really build a partnership with Google, right? Have them understand as well as you understand what it is you're trying to achieve. I really look at us as kind of the glue between the technology and the business problem being solved. And we're the ones that have to make sure that match is a good fit, and it's going to solve those business problems as well as improve the way that we're running the infrastructure under the covers. Like I mentioned several times, you want to align with the business. That's how you're going to create value, and that's how you transform. If you align with the business, the changes that you make are going to be transformative and not just upgrades. You need to standardize your capabilities list when you're running a platform and make it easy for the app team to focus on the business differentiation rather than focus on trying to architect a data platform. And finally, hire and retain people who are passionate about the vision. We're always looking for those types of engineers.
Thanks a lot, Bob. Those are really some great insights, which I'm sure will be very valuable for many companies who are looking forward to similar digital transformation journeys. I'm really excited about our partnership with Walmart and definitely looking forward to continuing this partnership as we go forward. I'm also very excited about Spanner's potential across the board, across multiple segments. Today, we have a number of large customers use Spanner, mainly because Spanner offers you all the good aspects of the relational database, while at the same time giving you the scale and availability equivalent of a non-relational database. Today, we have large retailers, gaming companies, technology companies, and banking companies use Spanner. And we are really focused on continuing to innovate on Spanner so that we can take this experience to the next level. On that note, I wanted to share with you some of the key highlights from our launches on Cloud Spanner. To start with, we launched support for PostgreSQL interface on Cloud Spanner. This is available in preview today. And as you all know, PostgreSQL interface is easily becoming the de facto standard for relational databases. With this launch, we want to democratize access to Spanner's capability with the familiar PostgreSQL interface for our customers. Continuing on the theme of democratization, I'm also happy to share with you that we added support for granular instances on Spanner. This is again available in preview today and will be in GA shortly. If you look at a typical Spanner instance as 1,000 processing units of compute capability, granular instances gives you the ability to provision 1/10 of that. In other words, 100 processing units. This makes it more cost-effective to run smaller workloads on Spanner. Continuing on the theme of cost effectiveness, I'm also excited to share with you that we recently launched support for committed use discounts. With this, you can actually commit to a specific level of usage for 1 year or 3 years, and in return get 20% or 40% discount respectively. These discounts apply to all your projects and all the regions where you are in. That way you're not logged into a specific set of resources. I'm also excited to share with you that Spanner Change Streams is coming soon. With change streams, you can easily access and integrate Spanner with other downstream systems. With change streams, pretty much in near real time, you can access all the changes in Spanner and update your downstream analytics engines. Or you could easily set up triggers to set up business logic based on specific data patterns. You could even use change streams to archive your changes in your Spanner database in near real time. All in all, with change streams, we want to make the data in Spanner more accessible and make it easily integratable with the rest of your broader data ecosystem. With that said, I want to call out that I've only highlighted a few of Spanner's key launches. We are continuously focusing on a very rapid innovation momentum. To give you a sense of it, just in 2021 alone, we had 58 launches on Spanner. We're going to continue on this momentum and looking forward to building more such launches in the coming years. In the end, if what we've shared today resonates with you, I definitely suggest that you check out our online material. If you're new to Spanner, you should definitely check out our Spanner Database Unlimited video series on YouTube. And of course, there are a bunch of sessions in Data Cloud Summit on Spanner. We also have a session focused on database ecosystem and strategy. Do check it out. Finally, I would like to thank you all for joining this session. Thank you, Bob, for sharing all your valuable insights on digital transformation. I wish you all the very best in your transformation journey going forward. Thank you.
Equifax has been on a mission to transform itself. We need to react more quickly. We need to be able to get new ideas into production. We need to be able to ingest new data sources and ensure the safety and security and data governance of all of the data that we hold. The cloud gives us the flexibility to do that.
When a consumer is seeking a loan these days, they are shopping around. The one that could provide them the answer fastest is the ones that they're going to choose. Equifax is able to deliver that instantaneous access to credit data that only a cloud-native credit bureau can do.
Google Cloud enables us to move to a more real-time basis around how we look at data. Banks want real-time information.
Moving to Google Cloud has enabled Equifax to accelerate how we bring innovation into the market, how we develop in new agile ways.
We've been on a journey to ensure that we could help the 90+ million Americans that are estimated to not have credit history.
This is so important in this new time of when young adults are finally getting to their first loan. They don't have a long history of credit, incorporating with consent information that we don't have in the credit file, how they paid rent or their telephone bills. Banks and institutions are able to use that information to open additional credit to them.
This strikes at the heart of one of our core principles of being the consumer-friendly credit agency that is working hard every day to put consumers first.
Drug discovery is really driven by the fact that the burden of human disease is tremendous.
How drug discovery is traditionally done is trial and error. Schrödinger is transforming the way scientists are developing drugs by allowing scientists to do more experiments on the computer and fewer in the lab.
High-performance computing and access to compute power has really allowed us to scale the number of calculations, the number of simulations we can do in trying to find the right molecule for the right protein for the right disease.
chemical space is almost infinite. The only possible way to explore that many molecules is to get access to massive compute resources that can only be available on the cloud. The partnership with Google Cloud allows us to bring medicines to patients more quickly by significantly accelerating preclinical drug discovery. We've taken it down from something on average around 5 years down to 2.5 years, and we've significantly reduced the cost as well.
We're able to design molecules with, in many cases, minimal activity at what are called off-targets that often lead to side effects.
We can do things we couldn't do before, and that allows us to develop medicines that we really could only dream about just a few years ago.
Goldman Sachs is a place where macroeconomic events are studied and analyzed, where transactions are conducted, where risks are measured. We're approaching brand new problems, building brand new businesses in spaces we haven't been in before. These are big moves for us. We are a wholesaler of risk. We need to be measuring, factoring, analyzing, and monitoring risk.
How do we maximize the compute power? How do we execute things faster?
It's absolutely imperative for us to be on the leading edge there and pick partners who we can really rely on in those domains. Google's capabilities are so extraordinary. The way that we factor compute cycles, the way that we express our technology, that's been transformed dramatically.
You basically have all these building blocks already existing that Google provides you that helps you to build a product faster, it helps you evolve faster.
Google's been able to both meet our needs in the moment and yet also be a great thought partner about where this could go over time.
Hey everybody, I'm Mark Porter, CTO of MongoDB. I am excited to be speaking at Google Data Cloud. I have been working around databases for over 30 years, and I love them because of the promises they make in terms of durability, correctness, availability, and operability, which frankly are some of the hardest promises to make in computer science. Joining me is Vadim Sapitsky, Forbes CTO. As Chief Technology Officer of Forbes, Vadim focuses on ensuring that one of the world's leading brands continues to stay at the forefront of technological innovation. He seamlessly led the team that managed the company's migration to the cloud, and he did it in record time. Prior to joining Forbes, Vadim worked for the City of New York, significantly advancing its internal technology tools. Vadim was born in Ukraine, earned a BA in computer science from Brooklyn College, and resides with his family in New Jersey. Over the last couple years, Vadim oversaw Forbes replatforming itself with MongoDB Atlas, our application data platform. Today, we're going to chat about that. Vadim, thanks for joining me. It's great to see you again.
Thank you, Mark. It's great to see you again as well. Thank you for inviting me.
I am so excited to get into this discussion about your digital transformation at Forbes and how the pandemic affected you. From what I understand, you've seen record-breaking audiences during this period. Is that right?
Yeah, during the pandemic, our audience has increased significantly, reaching 150 million users in our ecosystem.
That is pretty incredible. That's a lot of users, and it's an accomplishment. Can you explain a little bit more about how that happened?
Yes, in the past 25 years since we launched Forbes.com website, we've been focused on innovation and digital transformation. And it only accelerated in recent years. Our audiences have been growing steadily prior to COVID-19. However, our coverage of the pandemic and the foresight in creating breaking news team, as well as scaling our social presence, has driven an increase of audiences across platforms. One of the greatest drivers in our ability to rapidly pivot and support such large audiences, we feel stem from being fully integrated with Google Cloud and MongoDB Atlas. The strengths of combined technology enabled us to rapidly and seamlessly scale without any impact to our users and the stability of the website. It also puts us in a position to continue to innovate and thrive under any circumstances. The ability to consolidate data into one place and have it highly available with very little latency was really a game changer for us. Are you seeing the same circumstances with other digital transformations, Mark?
Wow, thanks for telling me about yours. Yeah, we absolutely are. Throughout the pandemic, we have seen more and more companies have to revisit how they present themselves digitally and physically to their customers. And so what we're seeing is applications being built by customers that run anywhere, that scale up or down as needed, and are easy to program against in this very dynamic environment, against any framework of services and languages and how everything is changing so fast in computers today. So all in all, we're seeing the flexibility of using MongoDB combined with the flexibility and elasticity of Google Cloud, providing the ability to scale and pivot with an ease that has never been possible before.
100% agree. MongoDB is perfect for digital transformation. How have you been able to innovate while still maintaining simplicity and flexibility?
So our North Star has always been developers. I think this single-minded focus is what has allowed us to provide products that are both easy to use and scalable. Once we focus on the developer and we just keep doubling down on that, we're able to provide better and better experiences. So rather than focusing on complicated things, we literally just try to focus on building great products that developers love. And so to that end, MongoDB itself is easy to use with native drivers in 14 languages, a flexible JSON-based data model, high availability and massive scale out right out of the box. And so you don't have to build servers, you don't have to build high availability, you don't have to choose a specific language. It's all there for you. And now we add on to this for customers like you by providing a modern platform that lets you do OLTP, add great writing of mobile applications, and then add search and analytics to those apps using a single interface based on open standards. However, all that said, and everything we do and Google Cloud does, innovation is still one of the hardest problems for customers like you.
It sure is.
So what we've realized is that companies today cannot outsource their innovation, and this is a bit of a change from years past. Given that a company's differentiation, regardless of your industry, comes through your ability to leverage software and data, you can't afford to provide inadequate software. And so this idea around innovating faster and more reliably is top of mind for the most disruptive companies I speak with. Their C-suite, who I speak with regularly, understands the roles that developers play and the questions they need to ask their engineering leaders. If we have more C-suite executives focused on how fast an organization can deploy and iterate an application, as well as doing that predictably around scheduled application deployment for the business, I think we see increases in innovation and digital transformation across the industry. Which begs the question, what led you to make the decision to work with MongoDB and Google Cloud?
Our decision to migrate to Google Cloud was made based on the toolset that it offers, scalability, and developer friendliness. With MongoDB Atlas, as with any service that we use, we first evaluate if there is a hosted solution and what set of features it offers. And MongoDB Atlas honestly checked all the boxes. It also was perfect timing for us because it was in the middle of a cloud migration. And we knew that we wanted to reduce latency between our applications and databases to a minimum. Simply put, we did not want to be in the database management business. Our focus is on building products, platforms, and new technologies instead of managing servers. So by eliminating routine backups, upgrades, and the need to over-provision our environments, MongoDB made it possible for us to focus on important things like innovation and our users' loyalty.
Wow, that is awesome. And I'm humbled to think about the complexity of the environment you work in. Have you seen any results from all of this work yet?
Yeah, to begin with, our migration to MongoDB Atlas and Google Cloud took just 6 months, so it was an aggressive timeline. And since then, we've seen really great results. We've seen 58% increase in speed to market. We now release 4 times more often than before. We've also seen 73% increase in initiatives delivered. And while our velocity has been really improving tremendously, we've seen 30% decrease in hot fixes and rollbacks.
It's inspiring to hear the role that your data platform and your cloud platform have played in your transformation. I'm glad you mentioned that the timing of your cloud migration served as an excellent time to rethink your data needs. Our collaboration with Google Cloud here at MongoDB feels very natural in terms of the technology we develop and how we approach serving our customers' needs. And that partnership gives DevOps teams a modern toolkit to maximize the value of their work and ultimately empower companies like you at Forbes to innovate. So the experience you've had is amazing. And I just have to ask, what's next for Forbes?
We're really excited about what the next era of information will bring. On the technology side, we're using more of the serverless stack, cloud native, AI and machine learning, as well as experimenting with Web3 tech. On the business front, we are obsessed with building our customer loyalty, delivering first-in-class experiences, and offering the most relevant products to our users. Customer-centric requires us to be a highly data-driven company, and we have an ambitious roadmap for our first-party data initiative. Data is really the key to us understanding our audience on the deepest level. And this understanding is what cultivates relationship with key segments. Those include C-levels, entrepreneurs, and other leaders. As a result, we are continuing to evolve our AI-powered publishing platform. We want to make publishing simple and make our journalists' lives easier in the same way that actually MongoDB has made developers' lives easier. Additionally, we're expanding our suite of consumer products, and this will bring enormous value to our customers. For us, innovation and transformation truly never stops.
Wow, I can absolutely empathize with that sentiment, and that is a roadmap of the future coming fast. That's so exciting. Vadim, I am so appreciative of you taking the time to chat with me today. And it has been amazing to see how Forbes is transformed. And thank you. And thanks to everyone else for attending Google Data Cloud Summit today.
Thank you, Mark. Hope to chat in the future shortly.
Hello, everyone. In this session, we'll talk about what's new with Spark on Google Cloud, and more importantly, learn about some experiences from Deutsche Bank. I'm Abhishek Kashyap, Product Management Lead at Google Cloud, and with me today is Balaji Maragalla, Director of Big Data at Deutsche Bank. Let us start with a look at open source. 99% of Fortune 500 companies use open source software today, and 80% are planning to further increase adoption over the next 12 months. And if you follow some of the open source projects online, you'll see that open source adoption in data analytics is also increasing very, very rapidly. And as companies migrate to the cloud, they are integrating open source analytics and processing into their core data strategy. And what that means is that they expect the same ease of use, scalability, and security from their open source platforms as from other cloud services. Just because it's open source, it does not mean that it can have a lower quality of service or security anymore. It has to be the same that the enterprise is willing to accept for all services. At Google Cloud, we have long focused on enabling customers to modernize their open source deployments with Dataproc, our managed data analytics offering for open source data processing. Customers like Metro, Broadcom, and Vodafone have been using Dataproc as their open source data analytics platform. This has simplified their operations, lowered the support and infrastructure costs, and most importantly, provided a significantly better experience to their end users. And as we have been on this journey for over 6 years, we have learned a lot from helping customers migrate some of the largest on-prem Hadoop deployments in the world to Google Cloud. And one of those learnings is the growth in Spark. And as the Spark usage has grown, we have been focused on delivering the best Spark experience on Google Cloud. At Next, our annual conference last year, we announced that we are doubling down on Spark, our commitment to making Spark a top-level solution on Google Cloud for all of your workloads, ETL, data science, and exploration. The core of these offerings is serverless Spark. Serverless Spark is the cornerstone of what we call a modern cloud service, because no one wants to manage clusters in the cloud. And this enables users to move away from infrastructure management and focus solely on their code. Now, just having a serverless data processing engine is not enough to unlock the different use cases. We know that different users prefer different interfaces. To address that, we have made Spark pervasive by integrating it with BigQuery, which is our data warehouse, Vertex AI, which is our data science platform, and Dataplex, which is our platform to build data fabrics. With these integrations, users can seamlessly use Spark from their interface of choice. And they do not have to create clusters in advance to do any of their work. And finally, we know that one size does not fit all, so we provide flexibility of deployment. Based on your needs and strategy, you can use Spark as serverless. You can deploy it on Kubernetes using Google Kubernetes Engine, or you can create managed compute clusters, and you can use Spark on that, which is what we have been doing for the last 6 years. Now let us look at what's new since this announcement last year. First, serverless Spark is now generally available. We have seen strong adoption from our customers for their Spark-based data processing pipelines. And we also have partners who are ready to work with you in implementing serverless Spark within your environment. Second, we are excited to announce that we now support interactive development through serverless Spark as well. For organizations looking to use Spark for data science and machine learning, we are launching support for serverless Spark sessions. This enables data scientists to develop on demand without provisioning clusters in advance, which in a lot of cases is an act of going to an IT team and getting resources provisioned. So this frees up the IT team from having to deal with these ad hoc capacity demands, and users can be productive by developing through their notebooks whenever they want. The serverless Spark sessions have been natively integrated with Vertex AI, which is our unified AI platform. The first integration is with Vertex AI Workbench, which allows data scientists to use Jupyter notebooks with serverless Spark without having to set up clusters in advance, or anyone needing to write custom glue code to make the two work with each other. With a single click, a user can start a Spark session and do interactive development. Now, when you use Vertex AI Workbench, Spark can easily be used together with other common machine learning frameworks like TensorFlow, PyTorch, Scikit-learn, and BigQuery ML. And since these are Google Cloud products natively integrated with each other, all the security, compliance, governance, and IAM policies that you define are automatically applied across Vertex AI and Spark, and all the way down to data access in BigQuery or Google Cloud Storage. Now, once you are ready to deploy these ML models, you can now schedule serverless Spark as a part of Kubeflow-based AI pipelines. And that brings Spark into your MLOps process as well, without any complexities of cluster management. So your ML engineers who are using Kubeflow can easily start having components which run Spark in the background without any infrastructure management. And the support for these in our managed AI pipelines is also generally available. Now let's look at a demo of using serverless Spark through Vertex AI Workbench notebooks. What you see here is a Jupyter Lab UI within the notebook. You will start seeing a new tile for using serverless Spark. And once you click it, it will ask you for some basic options for starting your Spark sessions. And there is no cluster that is running in the background. The session will start. Once you click this tile, you will have an option to use it as a single user notebook or use it with a service account, so then you can share it between users. You can provide network details here, and within advanced settings, you can provide a link to a custom Docker container if you want to, say, add more libraries or customize the underlying image. And you can also select from one of the existing containers within Vertex AI. And once you click Done, it will create the serverless Spark session. And once it's created, you can start using it from the notebook. And everything will work behind the scenes in this serverless Spark session. I also mentioned BigQuery earlier, which is our petabyte scale serverless cloud data warehouse. We have now integrated a PySpark editor into the BigQuery console, and that is powered by the serverless Spark backend. Now, data warehouse users can write and submit PySpark code from within BigQuery, and they will get the same serverless auto-scaling experience as they get with BigQuery SQL. So with that, you can now go to BigQuery and you can use either SQL or PySpark for doing your analytics on BigQuery data. And last but not the least, we are excited to announce that Dataproc on Google Kubernetes Engine is now generally available. With Dataproc Spark on GKE, you can deploy a GKE cluster, leverage the scaling capabilities that GKE brings, and use Spark with all the security and compliance features of Dataproc. And if you're standardizing on Kubernetes, this brings Spark to your Kubernetes environment very, very easily. We have had some strong adoption by customers for this feature during preview, and this is now generally available for you to use. If you're interested in some hands-on demos, please view the sessions from Spark Day at Google Open Source Live. Our engineers and developer advocates have put together some exciting content that can be very useful to get you started. With that, I would like to welcome Balaji from Deutsche Bank to share some thoughts about their data strategy and experiences with serverless Spark. Thank you, Balaji, for joining us. To start with, can you please tell us a little bit about yourself, Deutsche Bank, and your group?
Thanks for inviting me, Abhishek. Hi, everyone. This is Balaji Maragala. I'm leading data analytics platforms at Chief Data Office in Deutsche Bank. Deutsche Bank is a leading German bank with a global network, which consists of corporate bank, investment bank, private bank, and an asset manager called DWS. Deutsche Bank has presence across more than 50 countries with a large number of branches across the world and around 84,000 staff and managing more than 1.4 trillion in assets. Deutsche Bank also has more than 100 petabytes of data that we manage. And thanks, Abhishek, for having me to share my experiences.
Thank you. What is the landscape for data at Deutsche Bank? And what are some of the top challenges and learnings from your journey so far?
So the data landscapes in Deutsche Bank is made up of more than lots and lots of transactional systems and analytical platforms, and which are used across different business units. The operational data stores are made up of relational databases, transactional systems, and distributed event streaming platforms for real-time data events which are processed across different systems. The major data platforms which we have are around data warehouses based on Oracle Exadata platforms and Hadoop clusters, which are managed for data lake environments. Analytics, AI, and ML platforms are managed by centrally managed Jupyter Hub platforms and varied reporting platforms based on Tableau, Click, and we also have a lot of microservices serving these applications for analytics, utilizing both front to back aspects of the systems. The major challenges faced by Deutsche Bank are around infrastructure scaling, where we run large amount of central platforms, which are utilized by various business units, and upgrading those platforms to have latest and greatest software, and also managing the stability of those platforms with upgrades. Dealing with capacity planning issues, whereby we need to balance idle capacity with utilization to manage and derive value from the infrastructure, and also managing performance for various workloads running across BI, MI, BI reporting, management reporting, and data science workloads.
Thank you, Balaji. To address these challenges, can you please tell us a bit about your data strategy and your experiences with serverless Spark?
Sure. Deutsche Bank's data strategy is an enterprise-wide strategy whereby we want to make data an asset and drive value for our clients. We are planning to do that by enabling serverless capabilities as part of our cloud journey, where we want to encourage and enable citizen development by providing self-serve data infrastructure, and also provide secure and governed access, which is consistent across all business units and all use cases across the bank, and accelerate innovation use cases by enabling best-in-class cloud capabilities for our various user personas, such as data scientists, analysts, report developers, and normal engineers as well, including business users. The way we wanted to address that from as part of our transformation is started looking at what workloads do we run on-prem, and we started engaging Google with early partnership to enable serverless Spark workloads. And we run a massive Spark workloads on-prem, which range in thousands of jobs, which prepare data for various workloads ranging from data science and normal day-to-day regulatory reporting and anti-financial crime use cases. These Spark workloads currently we have are around based on Spark 2.4, which we are looking to migrate to Dataproc environments. And to do that, we are following the classic re-architect, re-host, and re-platform use cases. Where we have re-architect use cases, we are looking to utilize the latest serverless Spark adoption, which requires Spark 3.x code base, and which means that we don't have to re-host or re-platform our existing code base, which can be moved into Composer plus Dataproc environments, which we are creating. Based on these kind of transformations, what that would allow our data community is to utilize consistent migration pathways and consistent access across use cases. We are also looking at integrated security provided by Google platforms in terms of encryption, authentication, and authorization capabilities, which are very important as a bank for dealing with personally identifiable information. In terms varies across like Jupyter notebooks. Currently, we run massive central Jupyter Hub notebook state. We are looking to decentralize it and federate it as part of our transformation, which we by looking at adopting Vertex AI integration into serverless Spark. We're also looking at various other integrations whereby we have massive transformation program underway, where BigQuery is our central data warehouse capability, which will be provided across business units, and the notebook capabilities provided as part of BigQuery and Dataproc Workbench, which would enable multiple use cases and catering multiple personas, such as data engineers and data analysts who can interactively develop their pipelines, validate their data sets, and then deploy their pipelines according to our SDLC pipeline processes. So overall, bringing it down, the whole transformation, we are very much excited and we are well underway to deal with these things.
Thank you, Balaji. Quick question on serverless Spark. Based on your experience of using it, what are some of the benefits that you see from serverless Spark?
The major benefits which we see are around addressing our challenges, which I discussed earlier, in terms of like infrastructure management would be reduced massively. We don't have to manage any infrastructure because the serverless Spark jobs would be self-managed, and the scalability and the performance of the jobs will also would be reduced. The challenges around managing the constant race between utilization and capacity management use cases would also be eliminated by moving into serverless Spark and using various integrations with Vertex AI and BigQuery. What that allows us is we can focus less on infrastructure management and more on dealing with the business problems and providing value to our clients by prioritizing business use cases.
Thank you very much for sharing that. And thank you, Balaji, for your and your team's partnership and for sharing your perspectives with the audience today.
Thanks.
To wrap it up, we have some content for you. If you do want to learn more, you can visit our website. You can sign up for the private previews that we mentioned today. Our partners can do a Hackfest-style workshop with your own use cases if you are interested about those. And finally, for the GA products, you can just go to our documentation and get started. Thank you, everyone, for your time today.
Hi, everyone. Welcome to Data Cloud Summit 2022. We are very excited to have you join our session. In this session, we'll go deeper into how Google Cloud Technologies, BigQuery, and Looker together can help your organizations transform and achieve cross-cloud analytics. I'm Vidya Shanmugam, Product Manager for BigQuery Omni. I have with me Mary Newton, Outbound Product Manager for Looker.
Hi, everyone. Thank you so much for joining.
In this session, we'll share an overview of the various multi-cloud and cross-cloud challenges organizations face and GCP's approach to solving them. We'll talk about the core benefits of BigQuery Omni, cross-cloud transfer service, and Looker. We'll also dive deeper into cross-cloud analytics with demos on BigQuery Omni and Looker. Let's jump in. Multi-cloud is the new reality. It is not going anywhere. Over 90% of the organizations globally today rely on multi-cloud for their infrastructure needs. And this number is growing day by day. Organizations are not consolidating on a single platform or solution. Instead, they're expanding and cooperating their data silos and data footprint across multiple clouds. With multi-cloud analytics comes several challenges, such as data silos. Analysts and other data practitioners want easy and simple access and a single view to access their data across clouds. They also want simplified governance and security and management across clouds. Multi-cloud also create duplicate copies of data, leaving data inconsistent and not so fresh. Data analysts and scientists have advanced analytics needs. They want to access the data, analyze them, combine them, and visualize them to drive decisions for their organizations. They also want simple and predictable pricing models. GCP's innovative and open data platform provides a portfolio of tools to manage your multi-cloud and cross-cloud needs. In this session, we'll talk about two such key products in the portfolio, BigQuery and Looker. With BigQuery and BigQuery Omni, you can access your data, analyze your data, and combine them across clouds. With Looker, you can perform advanced analytics, get aggregated reporting, and dashboarding of your cross-cloud data. BigQuery Omni and Looker together enables you to manage your decentralized data, gain insights on this data, and empower users throughout your organization to get insights and take action. Let us first dig deeper into BigQuery Omni. We announced general availability of BigQuery Omni for AWS and Azure at GCP Next last October. BigQuery Omni is core to our multi-cloud strategy. It provides a differentiated solution that offers cross-cloud analytics at scale through a single pane of glass. Here are some of the core benefits our Omni customers enjoy. Omni allows you to cooperate your data silos through a single unified experience. It helps you integrate your data across clouds through a new capability called cross-cloud transfer. It allows you to securely analyze data across another public cloud through a fully managed infrastructure. You can query the data without worrying about any underlying hardware. Compute resources are local to the storage, allowing you to have a seamless data analysis experience. We are excited to launch a net new feature for BigQuery Omni called Cross-Cloud Transfer. Cross-Cloud Transfer enables you to bring a select set of results from AWS or Azure to GCP to combine your data. You can leverage broader GCP capabilities such as Looker, BigQuery ML on this combined data. Let's take a high-level look at why you need cross-cloud transfer, and we will be diving deeper into this in the demo. We have heard from many of our customers that just access to data in a different cloud is not enough. They want to be able to combine relevant data sets across different sources. For example, a retailer who has both online and in-store data in different clouds, organizations having buyer profile data and ads data in multiple clouds. They want to be able to combine the data, analyze the data, and drive business decisions in the simplest, most cost-effective way. Now that we've talked about how BigQuery Omni and cross-cloud transfer can address the various multi-cloud challenges, let's talk about our vision. It is to provide a cohesive platform for multi-cloud and cross-cloud analytics. Here is how the various technologies come together. BigQuery Omni provides access to your decentralized data through a single pane of glass. On top of this, you can get consistent fine-grained security and governance through a new feature called Big Lake Tables. In the future, we will also support materialized views for cross-cloud scenarios that will give you fresh data and insights. With cross-cloud transfer, you can bring data back to GCP just when you need it and what you need. All of this combined data and materialized views will be accessible through Looker, ML models for your advanced analytics needs. With that overview, let's jump into the demos for BigQuery Omni and Looker. To set some context here for the demo, cross-cloud analytics help you solve a common data silo problem. It can help combine data across clouds to create different aggregate models, such as customer lifetime value, average customer spend, etc. for a retailer. Because retailer channel data like online and in-store often lives in different cloud environments, it can be hard for analysts to access to combine the data to deduplicate overlapping customers or understand aggregate trends. BigQuery, Omni, and Looker can help address this challenge. Let's see how. In the first part, we will look at how Omni provides you the ability to analyze data wherever it resides. In this example, we are looking at a fictitious retailer who has both brick and mortar and online stores. They have their growing e-commerce retail data sitting within GCP in BigQuery. Let's look at the details for this table, and you can see that this is within BigQuery here. They have their in-store and point of sale data sitting in AWS, S3 for legacy reasons. Again, let's click through the details of this table, and you can see the source URI points to a file in S3. Into this, it takes me to an S3 bucket where you can see this file. For the purposes of this demo, let's assume I'm an analyst at the retailer The data silos across AWS and GCP causes challenges for me to look at the data or the business holistically. Typically, it's also hard for me to analyze data sitting in a different cloud like AWS without moving it or copying it. BigQuery Omni greatly simplifies this for me by letting me query the data sitting in AWS through a familiar BigQuery UI and SQL command. Let's take a look at this table that's in AWS and run a simple query against it. You can see that this query is similar to running a query against a table in BigQuery. When I run this query, a request is submitted to Omni clusters in AWS. You can see here the processing location is AWS US East 1. This is a BigQuery Omni region in AWS. Compute runs in AWS, co-located with where the data is in S3. I can grant access to the S3 file through an external connection that is managed by a service account. Once the query is complete, you get the results back in BigQuery. As an analyst, this makes my life simpler as I don't have to rely on other teams to import data. There are not duplicate copies of data that I need to manage, and I can access the data across clouds through a single pane of glass. Now let's move into the second part of the demo and see how Omni helps me combine data across clouds and simplifies cross-cloud analytics. As an analyst, it would be very useful for me to combine the in-store data and the online data, sales data, customer data, to analyze trends, get insights that can help tailor our marketing campaigns, loyalty programs, etc. With a new feature called cross-cloud transfer, I can just move the subset of data from AWS to BigQuery for advanced analytics. In the next few steps, I'm going to show you how we can create an aggregated table, starting with BigQuery data, that's online data, combining with S3 in-store data, filtered just to the fields that I need for my consolidated analysis. In the first step here, I'm going to create a new aggregate table, copying from the online transaction table, filter to the fields that are important to me. I can see this aggregate table is created. Preview to see all of the online fields here. I'm going to run a quick query so we can see all of the channels that are in this table here. And you can see that this represents the online channels 3 and 4 in this data set here. Now as the second step, I'm going to run an export query for in-store data in AWS, filtering to the columns I need and the rows I need. Once this query is successfully complete, you can see that the exported data consists of a file. Next step is the load feature, which is a part of the cross-cloud transfer service. This enables you to load data from a set of files into a BigQuery table. This command will create a new table in BigQuery if it does not exist. If the table exists, it will append to it. In this case, since we already have an aggregated table which has the online data, it will append the in-store data to it when we run this query. Once this query is complete, it has successfully loaded the data from AWS S3 into the aggregate table. Run the same aggregate query to look at the channels that we have in this table. And you can see that now it has a consolidated set of channels across online and in-store, and so we have a combined table of online and in-store transactions. Now that the combined data is in BigQuery, it can be joined with other tables in BigQuery. For example, if I want to look at all the customers in California to run a marketing campaign, I can join the aggregate table with the customer table in BigQuery. When I run this query, it will give me the list of all customer IDs that I can use them for my campaign. This is just scratching the surface of cross-cloud analytics. By accessing the consolidated table through tools like Looker, Data Studio, Connected Sheets, we can perform advanced analytics. With that, I'm going to transition over to Mare, who's going to show us the great capabilities of Looker and how it can achieve cross-cloud analytics.
Thanks, Vidya. In her demo, Vidya was able to manage decentralized data across AWS and BigQuery and bring key data sets together using the cross-cloud transfer service in order to gain insight into the overall performance of our retail business. Now that we have data centralized, we can use Looker to leverage the power of BigQuery and help users throughout our organization make decisions and take action based on those insights. Looker is a modern BI platform with a unified version-controlled semantic model that analysts can use to record their business knowledge using LookML, which is an abstracted version of SQL. Looker seamlessly integrates with BigQuery Omni, putting power and flexibility into the hands of users at query time. These Looker queries can support dashboards, ad hoc data analysis, operationalized insights, and even custom applications. So let's say I'm a data analyst working at our retail company. My job is to provide data and insights to users throughout our organization. I can run a few queries to understand order counts and revenue, but what if I want to understand something more complex, like customer value? Let's take a look at how Looker can help me do this by generating a model from our data in BigQuery Omni, calculating customer value within that model, and then visualizing and sharing those insights.
Here I am on the landing page of my Looker instance. I've already set up a connection between Looker and BigQuery Omni, so my first step is to create a new LookML project. A LookML project is where I can version control my code, collaborate with other data modelers, and infuse business logic into my BigQuery Omni dataset, like creating a calculation for customer value. In Looker, everything related to LookML models can be found in the Develop tab. So I'll click here and navigate over to Projects. On the top of the page, I'll click New LookML Project. I'll give my project a name. I'll just call it Omni Retail. And then I'll choose to generate this model from the underlying database schema, which is what Vidya showed in her demo. I have this already connected to my BigQuery Omni demo connection, which is the one we need for this demo. And I'll have this bring in all tables. So finally, I'll go ahead and click Create Project. Looker will now generate a new LookML project for me by scanning through all of the tables and columns that exist within the dataset that Vidya was showing, and then writing LookML to describe the entities that it finds. You can think of LookML as a collection of text files where you define the business logic and relationships that describe your organization's data. Looker has two different core types of files. View files are basically an abstraction of a table living in the database. And this is where you can use LookML to define new columns and aggregations. Looker will automatically generate one dimension for each column that exists in the underlying table, as well as a count measure, which is just a count star of all of the rows in your table. Model files are where we define relationships between different view files. So in our model file here, Looker has automatically created joins from our aggregate transactions table that's bringing together our online and in-store sales with other relevant tables such as products, customers, and channels. And this is all based on the relationships that are present in the underlying data. This forms what we call an Explore, which is the environment where users will be able to do ad hoc analysis against this dataset. Let's take a look at how that works. I'll go ahead and open up our Transactions Explorer here so that you can see what the end user experience is like. On the left-hand side of the screen is a field picker. Fields here are grouped by view. So just to sense check our data, I'll go into our transactions view and click on count, which is just a count of our transactions. And then I'll go into our channels and select ID and name. And finally, I'll hit run. This is just executing SQL directly against BigQuery Omni based on what I've defined in the model. And when I look at the results, I can see the number of transactions that we have against each channel. This includes, again, both online and in-store channels because of the work that Vidya did to bring this cross-cloud data together using the cross-cloud transfer service. I can quickly identify that online orders make up the largest portion of my overall order volume. Now let's build on this a bit further. Transaction count is going to be useful for seeing total order volume, but I want to understand customer value and to see whether online customers are more or maybe less valuable overall than my in-store customers. So let's navigate back to our model and add a few new measures to find out. I'll just open up our transactions view file with all of our aggregate data, and I'll add a few new fields here. My organization defines customer value as the average purchase value for an average order value, basically, times the purchase frequency for a customer. So I'll go ahead and add those measures in now. I'll start by adding a measure for my average purchase value. I'll give it a name. This is going to be an average. And finally, this is just going to be an average of our overall order value or sale price. So adding new measures or aggregations, it's a pretty easy thing to do. For the sake of time, I'll go ahead and just paste in the additional two measures that I need, which is the average purchase frequency rate. That's just an overall count of orders divided by my customer count. And then my customer value measure, which is a multiplication of my average purchase value times my average purchase frequency rate. I'll go ahead and save those changes. And then I'll navigate back to my Explorer and refresh the page to pick up those changes that I've just made. Now, if I navigate into my aggregate transactions data, I can see that I have 3 new measures available. So I'll go ahead and remove count. And what I'm really interested in is customer value. So I'll click to bring customer value onto my page, and then I'll hit run. I saw before that my order volume was higher for online purchases, but actually when I take a look at my customer value, I see a different story. In fact, my in-store customers are much more valuable from a lifetime value perspective than my online customers. And if I go ahead and visualize this, that becomes very apparent. So I can look at this as a bar chart and you can see a really drastic difference between in-store and online customers. As I work through this type of analysis, I can save it, I can share it out via email, Google Drive, or other collaboration tools, and I can even add it to a dashboard. That way I can share this information with others who might find it useful, because this could maybe influence how we structure a customer loyalty program perhaps, or set up marketing campaigns aimed at bringing customers back into my stores. Here's a very quick example of a dashboard that I prepared ahead of time that users might view to just get a quick pulse of how the business is doing. Here I can see order information across all of my channels. I can see my customer value, and I can even dig deeper into customer demographics.
You just saw how BigQuery Omni and Looker can be used to access retail purchase data across clouds through the BigQuery interface, to easily combine online and offline purchase data with customer geographic information to more accurately identify purchase segments, to create a unified semantic model that drives consistency in reporting, even as the underlying data changes, and develop a simple customer value model to identify your customer segments with the most opportunity. With the metrics we showed today, While they might seem a little basic, I hope they demonstrated how combining data segments across clouds leads to more robust analytics. This can result in better insight into business performance, more accurate marketing models, and ultimately improved ROI for campaigns and initiatives. With that, I'll pass it back to Vidya to wrap things up.
Thank you so much, Mer. Thank you everyone for watching this session and for being a part of the event. We hope you enjoy the rest of the Data Cloud Summit.
Hi, I'm Dane Hansen, Director of Product Marketing for Data Cloud at Google. I'm excited to welcome David Meyer, Senior Vice President of Product at Databricks. I'm joined also by my co-host today, Nicole McKenzie, who helps lead partner marketing for our Data Cloud group. David, it's great to have you here today.
Thank you, Dane. It's great to join you for the Google Data Cloud Summit.
Yes, welcome, David. I know the three of us have had the opportunity to watch the partnership grow since the beginning when we first launched, and it's amazing to see where we're at today.
Absolutely. Databricks is one of the most exciting data and AI companies right now. And David, you've been at Databricks for nearly 5 years, and we've been working together on Databricks since the launch on Google Cloud just a little over a year ago. Let's start with some of your recent observations about why there is so much interest in Databricks on Google Cloud.
Yeah, absolutely, Dane. So, I think Google's always been known for its technology. And Google Cloud has always been, engineers have been drawn to working on Google Cloud because of the fundamental technology there. And similarly, Databricks is known for its technology and the technologists at Databricks. So there's a lot of, shared cultural heritage there. So when Databricks was coming to Google Cloud, people were excited. And customers have been asking for this, to be honest, for the 5 years I've been at Databricks. So there was a lot of anticipation. And then the ability to leverage this open source core capability to run all of your data and AI on these combined systems, well, customers want it, but they also need it to achieve their goals. So I think there's been a lot of interest. It's been a very exciting year.
That's fantastic, David, and it has been a pleasure to work with you. So let's talk a little bit about the integrations that Databricks has with Google Cloud. Can you share a little bit with us how Databricks and Google Cloud are partnering together?
Yeah, so I talked about the data and AI coming together in this open lakehouse and the open source foundation of it. So customers are coming to this because they need to operate on all of their data as it's coming in and as it's being modified, and do the data science and machine learning directly on top of that. So Databricks operates on the Google Cloud that customers love, and it makes the value in it higher. So basically, when people are managing their data in Google Cloud Storage, all of their data storage, or in BigQuery, and then orchestrating it with Google Kubernetes engine, Databricks just runs on that infrastructure. So what you have in Google Cloud, We leverage that and we make it more powerful. And then the Google tools like BigQuery, Vertex AI, and Looker for the different types of engineers to operate on that data, those all plug natively in. So you use the tools in Google BigQuery and Google Cloud, and then the Databricks lakehouse environment based on standards just layers on top of it, and you can use it all together. And that's what customers love.
Hey, I love this lakehouse approach, David. And I love that we're working together on connecting these open standards in such a way that gives more flexibility and extensibility to our customers. And it's great to see you're using our cool products like BigQuery and Vertex AI and Looker, and of course, running it on Kubernetes. So thanks for all that. But I think also we see so many of these integrations come to life with our customers. And through this partnership, I know we've collaborated on a lot of these different partnerships. Now we're starting to see customers apply these in the real world. Do you have any examples you can share with us today on some of these cool examples?
Absolutely. Let me first take a step back. So data and the AI that derives insights from it is the lifeblood of the modern company. Most companies, all industries are transforming themselves around data and AI. So let's take this. We have a mutual customer. It's a Fortune 500 logistics supply chain customer. So imagine running a supply chain in the last couple of years. It's bonkers. Like COVID disrupted everything. There was all kinds of massive changes that affected your supply chain. So in the old world, you had kind of a data stack on one side and AI stack on the other side. And you're preparing all of your data, munging all of your data, and you might get it cleaned and updated once a day. Okay, then you try to bring it over to the other side of the stack and get insights through machine learning and things like that. You can't do that anymore. You have to have real-time insights. So bringing this data and AI together into this lakehouse, all sitting on top of GCS, all of the sensor data in the supply chain and the IoT data can land right in the lake. And the machine learning and AI can happen right on the lake. So instead of what this company was doing before was they had a daily refresh of the data they operated on, now they have real-time continuous insights into the data coming in from their supply chain. So if there's a problem at 9 a.m., they can act on it at 10 a.m. And that's necessary in today's world as hyper dynamic it's becoming and the supply chains have to adapt. So that's what customers are able to do, bringing the Databricks technology on top of GCP.
What an amazing example, David. I love how we're working with customers. And one of the customer trends we are observing is the growing adoption of leveraging a simple and open approach to analytics and AI in one place, on top of the data lake. Are you seeing any similar patterns emerging?
Absolutely. I think the openness is core. I mean, the stacks of old, they locked you in. And then every 10 years, you had to re-platform. But you can't operate, if your whole business is running on data and AI, you can't fall into that trap again. So bringing data and AI into this common lakehouse that's based on standards, I mean, basically, together, Databricks and Google have to earn your trust in business every year, or else you can just take your data into another system, right? So that's how we have aligned incentives with our customers. So let me take there's a US grocery delivery service, okay? And they were able to bring all of this data, and Databricks has a specialized connector into BigQuery, so it can dig into BigQuery and push down queries and things and take all of that data and do machine learning directly on top of it. So when you add those performance capabilities and not having to move the data around, this delivery service was able to basically 10x their performance. The job that took 10 hours took 1 hour. They could improve the performance 750%. Now, since a lot of the consumption-based cost is on this performance, they were able to reduce their cost by $300,000 a year for the first use case they brought onto this platform. So their performance dramatically increased, their cost dramatically went down, but what's even more important is now they can do more. They can do things they couldn't have done before because of the limitations of the system. And the open source capabilities means they can plug all of their data engines into this this same platform, the Databricks on top of Google Cloud. So those are the things they're able to do when they bring everything together into one system based on open standards.
Super impressive, and just another example of how we're partnering together with customers. On that note, thank you, David, for joining us today. Together, we are excited to deliver such a strong business value to customers. So any final thoughts?
I mean, first of all, thank you to the audience for being here, to Nicole and Dane for doing this with me. The thing I'm most excited about is that we've just scratched the surface. We're just beginning. So everything we see customers doing, we see industries transformed across, every kind of capabilities we see. That's just maybe 1% of what's possible and what'll be happening in the next bunch of years as we bring the technology of Databricks together with the technology of Google Cloud and this open systems to do data and AI together. So I'm just super excited to hear the rest of the content today and to see what these customers do over the next bunch of years.
This is awesome. Thank you, David. Thank you, Nicole. And thank you for joining the session today on the Data Cloud Summit. I'm so excited about what we've discussed about the open data cloud on Databricks. So many great things that we're doing together. And it's just great to see the synergy between the two companies. So once again, thank you again, and we'll see you next time.
Hi, everyone. My name is Erwin, and we are here to talk about AI notebooks and how to. In this session, I'm joined by my colleague, Brad Myro.
Hey, everyone. Happy to be here.
So in this session, we'll give you an overview of Vertex AI Workbench, and we'll do 2 demos on how to use Vertex AI Workbench and Spark, and how to use Vertex AI Workbench with BigQuery and the wider Vertex platform. We don't have a lot of time, so let's dive into it right away. So we believe that a notebook-based workflow are the key to production-grade data science because it offers minimal overhead and waste. It's important as a user, but also as an ITer, to provision resources and to apply organizational controls. Also, it's key to have a seamless handoff between your IT systems, of course, your data systems, but also your workflow systems. Often we see that it's not in place. And also as a user, we like to have a unified development experience, accessing our data, engineer our features, build our models, and bring all of this into production. To cater to these needs, we recently launched and introduced the Vertex AI Workbench, which is a next generation notebook. It's a single interface for your data, analytics, and machine learning workloads. So it's a Jupyter supported workbench environment where we have an enterprise notebook ready for you to use, and we offer connectivity and integrations with our data analytics capabilities. But also we offer integrations with the wider Vertex AI platform. Also, together with our NVIDIA partner, we made it possible to launch a Vertex Workbench notebook from a single click from the NVIDIA NGC Center. So NVIDIA NGC has a wide range of NVIDIA GPU optimized AI software and libraries for you to use. Let's dive a bit deeper into what is the Vertex AI Workbench or what do we offer. We offer managed notebooks and we have a multi-kernel UI support. There's a managed pool of resources for you to use to go from instant provisioning and switch between resources. And also there's the option that if you don't use your notebook for a while, it will go in idle shutdown. And it's there again for you to use when you go back to work. And of course, we have integration with our core data analytics capabilities like BigQuery, or if you want to leverage Spark, as Brad is going to show you later as well. And then once you work with that data, you processed it, you can do training using custom Vertex training, AutoML, or BigQuery machine learning. And then once you have that machine learning model ready, you can create a pipeline, you can deploy on Vertex pipelines, and then take that model into production. So as mentioned, integration with the Vertex platform is a core capability of Vertex AI Workbench. So we're going to see some of those integrations later on as well. But the Vertex AI platform is the go-to platform for data scientists to build their end-to-end machine learning use case. So depending on your requirements, depending on your use case, there's technology for you to use on the Vertex AI platform. What we're going to see later on is the Vertex AI managed pipelines, and we're also going to see Vertex AI predictions, and of course, Vertex AI Workbench. So let's dive into one of these demos right away. I'll hand it over to Brad. Brad, over to you.
Awesome. Thanks, Erwin. So earlier, you heard about several exciting announcements, including serverless Spark through BigQuery, Dataproc on GKE for Spark, and what we're now going to spend more time on, which is serverless Spark Interactive and its Vertex AI Workbench integration. Now, before we dive into our demo, I just want to talk a bit about Dataproc as well. Through Dataproc, you can consume Spark and a myriad of other open source tools however you see fit. Some of these include Jupyter, Pig, Tez, Zeppelin, Scala, Presto, Dask, and NVIDIA's Rapids framework. Dataproc also enables access to our larger suite of tools on Google Cloud, including BigQuery, Cloud Storage, Spanner, Dataflow, PubSub, Kubernetes, and, of course, Vertex AI and Vertex AI Workbench. Now, to talk a bit more about the serverless Spark integration through Vertex AI, data scientists can use Spark for development from Vertex AI Workbench, as well as Vertex AI seamlessly. You have the built-in security and authentication features that Vertex AI provides. You have Google Cloud security and user access that are applied to your Vertex AI Spark jobs. And you can also integrate Spark into ML ops workflows. You can execute Spark code through Vertex AI and Vertex AI Workbench, as well as through Vertex AI pipelines and Kubeflow pipelines. So with that, let's dive into a demo.
So here we are inside of the Dataproc Cloud console, and this is where all of our Dataproc clusters will be listed. If I wanted to create a new one to be used with Vertex AI Workbench, I would press Create Cluster. I can then provide a cluster name, something like my cluster. And then there's some other configurations here we can set, such as the region. But importantly, to work with Vertex AI Workbench, we'll need to enable Component Gateway, which provides access to the web interfaces on the cluster without needing to create an SSH tunnel. And then also we would need to enable the Jupyter Notebook optional component. So then we could go ahead and press Create, but we actually have a cluster already here that I provisioned earlier that we'll use for the demo. Now, if we want to take a look now at our Workbench, we could go to Vertex AI and then Workbench. And here we'll see all of our notebooks that are available. And if we wanted to create a new one, you can press New Notebook. And then similarly, we have some other configuration options here. So we have we can change the name. So for instance, it could be like my instance, let's say. You can also configure the region. Then there's also some advanced settings here that you can set. So you can use a custom image for the Workbench instance. You can also configure the machine type. You can enable idle shutdown. And then you can also enable things such as networking and some security options, such as having access to a terminal on the instance. So once again, we already have a Workbench available that I created earlier. So I'm just going to go ahead and open it. So here we are inside of our Vertex AI Workbench instance. And before we dive into this launcher tab, let's actually take a look at some of the tabs that we have available to us on this left-hand sidebar here. So the first one is our file browser, and this one will list all of the files that we have available to us in our instance. Next up is this Google Cloud Storage tab, and this will show us all of the storage buckets that we have available and that we could also browse through. Here we have our BigQuery tab, and this will list the BigQuery resources available, and so we can browse through some of these. For instance, I can click on this BigQuery public data, and this will show us all of the data sets that we have available. Next, we have this running kernels and terminals tab, and so here this will show us just the the ones that we have that are currently running. Next, we have this tab to show a Git repository that we can connect to Vertex AI Workbench. Here we have a table of contents tab, and let's say we had a notebook that was that had Markdown written in it. It would actually be shown here, and we can click on one of the headers, and then it would bring us to that section of the notebook. Here we have the notebook executor tab, and so what we can actually do is we can schedule executions of any of our notebooks, either scheduled or ad hoc, I should say, and so those would be listed here. And then last but not least, we have this tab for enabling third-party extensions within JupyterLab. So now let's talk about what we have available to us in the launcher here. So we have a couple high-level components. We have notebooks, consoles, and other. And then under other, you see that we can enable something such as a terminal, or create a text file. But let's take a look at some of these notebook options. So every instance of Vertex AI Workbench by default will come configured with a Python kernel, a PyTorch kernel, R, TensorFlow, and XGBoost. And then as we just announced, you now have access to serverless Spark. So what we can do is we can click on this, and then we can create a serverless Spark session by providing a name, choosing the language, the region, some network configurations, and then we also have the option to configure things such as a custom container image or a Metastore service or a history server. So I've actually gone ahead and created one of these in advance. We have here this PySpark on the Summit session, and so this would connect us to our session. So here we have some code that will pull data out of one of the BigQuery public data sets, namely the New York City Bike public data set. And then using the Spark BigQuery connector, it will actually load some data and do some basic exploratory data analysis on it. Now here we have, we can see that this is connected to that Summit session that we were talking about earlier, but I can also change this to any other kernel that I have available on in my environment. So we have those local kernels, but then we also have any one of those kernels on one of our Dataproc clusters. So we'll just stay on the serverless session here, and then we can see that we can actually go ahead and execute some code. Now, a couple other things that I want to talk about here include this execute button. So if we click on this, this pulls up a window where it allows us to submit notebooks to the executor feature. And so we can set a name, we can choose the machine type that we want to have configured here, the accelerator, and then also the execution. So this can be one time or scheduled. And then we would end up pressing submit. And then last but not least, let's actually create an extra cell here. And I want to talk about this feature here, which is a button that enables BigQuery. And by pressing this, we now have the ability to actually execute SQL commands against BigQuery. All right, so that's what I have to show to you today. And now I'm going to toss it back to Erwin. Erwin, back to you.
Thank you, Brett, for that awesome demo. Now let's go into the next demo and have a look at BigQuery and Vertex AI Workbench. From Vertex AI Workbench, you have direct access to query data that sets into BigQuery. You can use the interface for this, or you can use the code to submit your queries to BigQuery and even create a pandas data frame. Why this is important is this offers you the ability to leverage data that sits in BigQuery, but to also have access to our BigQuery public data sets but also feed this data into the different steps of your machine learning workflow, which helps with reducing your data movement. So let's dive into the demo and have a look on how some of these capabilities from Vertex AI Workbench and the integration with BigQuery works. Okay, we're back at the Google Cloud Console for the second demo. We've just seen an awesome demo by Brad, and we're gonna start our demo in a similar way using a managed notebook that's part of the Vertex Workbench. As you can see, I've already created a workbench environment, a managed notebook environment. And we're gonna go through a demo where we're gonna create a BigQuery machine learning model, and then we're gonna automatically deploy that model onto our Vertex model registry. So this is a very new functionality. So you can train in BigQuery, and then we can deploy the trained model on the Vertex platform. And once it's registered on the platform, we can deploy it as a REST API and get predictions from it. So that's what we're going to see in this demo, and I would suggest we dive into it right away. So let's go to our notebook environment. So this is a managed Jupyter Lab environment, and I want to point out one of the functionalities that we mentioned during the presentation is that from here you can explore data sets that are available within BigQuery. So the ones that you see here are the public data sets. And for our use case, we're going to use the penguins data set where we're going to predict the type of species based on some of the input features. Here I can also query data that's available in BigQuery, and I can see the results in my notebook environment. Okay, so let's move to our notebook. So as mentioned, we're going to create and train a logistic regression in this case that's going to predict the type of species of a penguin. So here you can see that we're specifying the type of models and our label scope. And then once the model is trained, we want to register that model on the Vertex model registry. So after training, it will be automatically deployed on the registry environment. And from there, we can take it and deploy it as a REST API. And we're going to train this on a public data set. And I could run this query from this cell using the magic cell capabilities for BigQuery, but I'm going to go to the BigQuery interface because I think it's more fun to see. So this is the same query for us to create a model and to register it on the model registry. So we can run this query and then the training process will start. Of course, training a machine learning model takes a bit of time. So I already prepared a trained model for us. So here's the logistic regression. We can see the training options or the hyperparameter specifications for this model. We can see how it performed during training. And we can also evaluate the performance of our model. So these are the aggregated metrics. And if I scroll down, we have our confusion metric here. So as mentioned, this model has been automatically registered on the model registry. So let's move to the Vertex platform interface. So if we go to Vertex models, and this is where we can find the model that we just trained using BigQuery machine learning. So this is the penguins model. I'm going to select this one. And then if we see here, we can go to model properties and we can see that the source is a BigQuery machine learning model. So we are pretty happy with this model. So it's time for us to deploy this model and start using it in production. So I'm going to select deploy endpoint so I can do the deployment from the interface. I'm going to add it to an existing endpoint because we already have a use case in production and I want to add this model to it. So I'm going to select that endpoint name. I'm going to say continue. And now I have to specify a traffic split. So what I'm going to do, I'm going to specify a 90. Yes. 10. And this one I'm going to set to 0. And I'm going to set this one to 10. So this is a new one. We're going to slowly build up the traffic for the new model. I'm going to leave the minimum number of compute nodes to 1. And I'm going to also leverage the advanced scaling options, and I'm going to specify the compute here. For this use case, I'm not going to use a GPU accelerator. And now I'm happy and I'm done. I'm going to say, OK. Check. OK, we have 3 models that are part of the endpoint. This is the existing one, and this is the one that we're going to add with 10% of traffic going there. Deploy. So what you will see now is that the deployment is starting. And if we move to our endpoints and we go to the Penguins endpoint, we can see the existing models are already here. So the new deployment is going to start, and it will also change the traffic split. And so these are all the models that are associated with the endpoint. So we've gone for the model registry, and now we started our deployment. So of course, this takes a bit of time as well. And I also want to show you how you can test the endpoint. So how you can send some data to it and actually do a sample request. So here, if you select one of the models, this is the existing one. You see here on the right, you see sample requests. And here you see an explanation on how you can do a sample request. This is also something you can do from your notebook environment. So if you use the library, so the SDK for interacting with Vertex, you can specify an endpoint. So this is the endpoint ID. So that's the ID associated with that, with endpoint. We then, of course, need some data that we're going to send to the endpoint, and then we can make a prediction. So we're going to send the JSON to the endpoint, and we will, in return, we'll get the results or the prediction of the model. So in this case, a class for the type of penguin species. So what we've seen is training a model using BigQuery machine learning, automatically deploying that model on the Vertex model registry, and then taking that model and deploying it as a REST API using the Vertex UI. And then we've seen how we can make a prediction to test that model. So that was it for the last demo. I want to do a big shout out and thank you to Brett for the awesome demo on Spark and Vertex AI. I hope you enjoyed this session and enjoy the rest of the Cloud Data Summit.
I'm Leah.
And I'm Gabe. Welcome to the Data Cloud Summit to all of our data scientists, engineers, developers, and professionals. We hope you've enjoyed the sessions in the summit so far.
In this session, we're going to take complex, fragmented data systems, simplify them, and bring them together on a massive scale. In our demo, we'll show you how Google Cloud can help a company build a new application that delivers great consumer experiences, while keeping it simple, open, and integrated for developers.
Meet our fictitious company, Symbol Solar. They own a solar company that sells renewable energy products and allows consumers to track their savings and their ability to resell excess power. As a part of their product revolution, Symbol partnered with Google Cloud. Symbol wanted to build a modern data cloud that takes information from various sources to power a unified insights platform.
And Symbol relied on an old database architecture and struggled to manage all types of data across multiple clouds. But now, Symbol wants to deliver a platform that makes new data easily accessible to their consumers so that they can better understand their own energy usage.
The new architecture will enable Symbol's developers to go faster by providing a serverless, scaled experience for application development, data science, and data insights. And finally, Symbol wants to introduce modern B2C interactions, including gamification, to help change consumer behavior in real time and make the whole consumer experience a little more fun.
That's right, Gabe. And to summarize Symbol's data cloud transformation, we'll focus on 4 objectives. First, empowering developer experiences by using serverless wherever possible. Second, enabling petabyte-scale queries that can be performed in real time. Next, unifying insights across multiple clouds. And finally, simplifying business intelligence with a unified semantic model.
So to achieve this, we're going to show you some of the latest innovations from Google Cloud as of today at the Data Summit. We're going to leverage 5 key products. Cloud Spanner, the relational database that scales with our mission-critical data. BigQuery, the industry's leading data warehouse solution. Serverless Spark, so we can build new machine learning models without managing infrastructure. Vertex AI, to deploy and monitor those models. And finally, Looker, to serve all of Symbol's data for its business users.
And by combining the differentiated power of each of these products, we'll create a modern architecture to serve both internal and external data use cases.
Oh, and by the way, any of the architecture diagrams that you see was built from an awesome new tool built by our one and only Priyanka.
So cool. Thanks, Priyanka. All right, so let's explore how this architecture comes to life in our app, Symbol Solar. Here, we're starting at the home page, viewing our consumption data and details on our house. Now, energy consumption is being surfaced from BigQuery, using Looker's API and underlying semantic model, while our personal information is being powered by Spanner.
It looks like we're actually seeing some consumption in the app. Can you dig in some details a little bit?
Yeah, let's drill into those details. So as we look deeper into this detailed usage, we can even see recommendations being surfaced for how to change our energy consumption.
We'll cover this in a bit, how easy it is for data scientists to build production-grade models, both ML and semantic, in our architecture.
And check this out. I can take direct action from this app, so setting up new tools like power monitors or other IoT devices. But with millions of devices for our app to manage, we need a highly performant and globally consistent database. So thanks, Spanner.
For the developer, we've simplified how easy it is to build, maintain, and enhance our consumer products.
Yeah, that's right. So now let's go a little bit under the hood to show just how we've enabled this consumer journey using our Google Cloud architecture.
Our consumer journey all starts with our ability to collect and transact on data at scale. With our sensor data and user transactions in Spanner, we know our application will seamlessly scale for millions of users across the globe and with 5 nines availability. Spanner's fully managed capabilities also ensure that our team can spend less time on database tuning and more time on feature development that benefits our consumers.
And let me just gush a little bit more about Spanner. So for our developers, the new Postgres interface means they get the familiarity of working in Postgres, but with the scalability and reliability of Spanner. Plus, with granular instance sizing, we can leverage Spanner in more places during our development workflow and make sure we have the right sized environments for our development needs.
Once we've generated data from our application and from our devices, we ingest and transform data across these sources and many others using standard SQL with BigQuery.
So just to add some more color here, we have our data being assembled across Spanner using federated queries, from AWS using BigQuery Omni's cross-cloud analytics, and also from our new Google Cloud Data Lake using big lake capabilities in BigQuery. So for each of these data points, all we have to do is create a connection to the data from BigQuery, and then we can just use SQL to query data from any source. Plus, we can control our data using the same BigQuery access policies across both external and BigQuery native tables. Meaning, just like Gabe said, even though our data sources are spread across different infrastructure, we can prepare this data for analytics using standard SQL.
Next, using BigQuery and serverless Spark, we can build and submit our notebook using a single pane of glass. This enables us to run massive pre-processing and computation for ML using the best tools for the job.
Now this is huge because we don't need a Gabe to understand the underlying mechanics in cluster setups and configurations.
Right, so using serverless lets developers focus on development and Google to focus on giving us the best and right size infrastructure for the job.
So we've talked about our architecture at a high level, but now let's focus on how this allows us to scale with our consumer growth. Like we said before, we used to rely on old database-centric architectures. So data science at scale was really a struggle.
While we had data science ambitions, in reality, our data science team spent most of their time trying to get data or being production support, trying to deploy and troubleshoot models. Our goal with the new architecture, in addition to modernization, is to let engineers in each area do what they love.
And with this new architecture, our developers can focus on their specialties, meaning we're better equipped to build high-quality data products.
It's also good to mention that in the prior architecture, we would have had to stitch this together using many products and many code bases. Using Google Cloud, we can be intentional about using products that all work seamlessly together.
Okay, let's jump ahead and talk about how we provide our transformed data and models to the application. Gabe, can you talk about how we did this at Symbol Solar?
Sure, so let's start with our data science flows. For our data scientists, we built our models using serverless Spark that we were able to execute from BigQuery's UI. Once we have our models built, we can leverage the MLOps capabilities in Vertex AI to provide end-to-end management of both our models and our processes.
Right, and once our models are created, they're checked into the Vertex AI model registry. Now this lets us see changes that happen in our model, giving us complete version control.
And then next, we create a live endpoint with Vertex AI endpoints. This scale-to-zero service allows us to not worry about how much infrastructure we have for our models and focus on using Vertex AI endpoints model management capabilities to track our model effectiveness.
Not only that, but we can build faster because our data scientists can use programming languages that they're already familiar with. And with frameworks for model deployment and monitoring, MLOps processes can all be performed in a single pane of glass. So far, this new architecture has really simplified the amount of non-core work that our teams have to do. Now, we're crunching petabyte data sets across our clouds, unlocking more use cases, and further transforming the business.
Okay, so let's walk through that last component, how we democratize access to this data, serving it up to our internal BI users and our external consumers. Leah, you're a product manager. Can you walk us through some of the capabilities for this application?
Of course. So with Looker, we create a modern, governed, universal semantic layer that queries data across our data clouds. The semantic layer contains our business logic, written as code, that can be defined and shared across our entire organization.
Looker queries databases to get the freshest available data and then serves insights for the model to users. Insights can be served in dashboards, alerts, embedded experiences, or custom data applications.
And not only can our team consume data in the Looker UI, but they can also access governed data in Data Studio, a connected Google Sheet, like I'm showing over here, or even other BI tools. Now with these new integrations, our stakeholders can work in the tools they're most comfortable with, while still giving our analytics team the confidence that these metrics are accurate, since they're all coming from our universal semantic model.
We can also embed insights to their direct workflows, removing the BI swivel chair operations where users need to look at a dashboard and then take action on another screen. Similarly, for our application engineers, we're going to leverage that same universal semantic layer. And from there, we can share our insights from our data using feature-rich APIs, extension frameworks, or embedded analytics.
And not only does this model give us confidence in our data, but it also ensures that all our information is securely managed, including row-level security. This means that when our Symbol Solar app users query data, they only see what they're supposed to see, so their own data.
And last, Looker enables us to serve our customer across clouds and databases using the universal semantic layer. We can access, govern, serve, and take action on any data that's available using a SQL connection and provide insights from across the data cloud. For Symbol, this allows us to create a differentiated data product. We can increase app stickiness and provide premium product offerings for customers to learn from and act on all the valuable insights that we've created.
Exactly. Okay, so to wrap things up, let's quickly review Symbol's Data Cloud architecture. It starts with data that we collect from our products and within our applications, which then land in our data lake, transactional databases, and other clouds. That data is then unified inside of BigQuery.
Next, our analysts and data scientists can work with the data using serverless platforms like Serverless Spark and Vertex AI, so they can focus on the right development tasks. And last, we leverage Looker to democratize insights and allow both internal and external stakeholders to take action, closing the data feedback loop. All of this is made possible and simple with Google Cloud.
So that's a wrap on our exploration of the Data Cloud made simple. Thanks to all of our data engineers, scientists, analysts, and professionals who are able to join us for the Data Cloud Summit. And Data On.